And that's pretty much it. I would like to give it back to Bhuvana. Thank you so much. Thank you so much. And I'd like to thank the community, right? So, Bhuvana iterated this point that this is by the developers and for the developers, and there's no company behind. Of course, we get support from all of these sponsors, but these are the communities. All of these are smaller communities run by people, right? By passionate people. They come together, they bring the speakers, experts on board, and they share the knowledge that they have. And event like this would not have been possible without these support from these communities. And huge round of applause for all the community organizers. Thanks once again, and we are very happy and humbled to have all of you here and continue this journey. Thank you so much, and I'll leave it to Bona.
Thank you so much, Elias, for the opening note. And it's always great to hear from a passionate leader like you. Next, I would like to welcome our today's chief guest, Ms. Vanitha Venugopal, CEO of IIT Hub and Head of Incubation Startup Tamil Nadu, and thank her for the graciously accepting our invite to be our keynote speaker also. Ms. Vanitha Venugopal brings a wealth of experience and expertise to our event. Holding an engineering degree from our very own Chennai College of Engineering, Gimbi, and a master degree from Ohio, she enhanced her skills with an executive MBA from
where
Stanford.
I can fit this in.
Vanitha's leadership journey, including roles at Dell Computers and
No, I
C-level
just have some
executive
notes in
positions
it in case I
several
want to see.
startups and government institutions, both in India and on international stage, showcases her skill in driving business strategy and fostering innovation. Currently based in Chennai, her commitment to Tamil Nadu's development is evident through her role as IIT CEO and in her earlier role as the Chief Strategic Officer to the Chief Minister's flagship program, Naan Mudalvan. With 25 years of global business experience, Vanitha is a significant influencer in technology, startups, and government initiatives, contributing greatly to the growth of Tamil Nadu. We take immense pleasure in welcoming her as our chief guest and a keynote speaker of the day. Let's give it up for Ms. Vanitha Venugopal. I would now request Karthikeyan to honor our chief guest. Let's hear. Light and brightness symbolize positivity and motivation and the bringer of good. To begin our event on an auspicious note, we will now have the lamp lighting ceremony. I would request Ms. Vanitha Venugopal ma'am to do the honors and also the following dignitaries to step forward for the lighting of the lamp. Now, the lamp lighting ceremony begins. I would like to invite Ms. Rajalakshmi Srinivasan, Director of Product Management, Zoho. Anbumani, the core organizer of AZConf. Deepak Rajendran, Community Program Lead, Microsoft, our community leader as well. And Karthikeyan, CTO of Pro. Please do the honors of lighting the lamp. Let's hear it for them. Give it. Put your hands together for the lamp lighting ceremony. Thank you so much everyone for doing the honor. As the glow from the ceremonial lamp brightens our space, so too will the brilliance of our esteemed keynote speaker enlighten our minds. Please give a warm welcome to Ms. Vanitha Venugopal as she takes the stage to deliver the keynote. Please give it up for Ms. Vanitha Venugopal.
They're just trying to switch it on. Hello. Good to go. You can get started.
Please give it up for Ms. Vanitha Venugopal for the keynote speech.
Good morning, everyone. I'm sure எல்லாரும் காலையில ரொம்ப சீக்கிரம் எந்திரிச்சு IIT வரைக்கும் ட்ரை பண்ணிட்டு வந்திருப்பீங்க. So I truly thank for taking the time to come here. So when Karthik came 2 days ago, meeting him for the first time, a very energetic young man comes and invites me for this AI cloud conference, and I tell him very honestly, yeah, I'm a technologist, but you have a great lineup of speakers, so what is that you want me to come and talk about? So I clearly told him that the tracks and the lineup for the 2 days is astounding. So I'm just going to talk about just few life lessons that has helped me to reach where I am today. Coming from a very simple, humble family, Tamil Nadu, whatever little I have achieved could be maybe, was possible based on, some right connects, right decision making, right mentors in my life. So I decided that maybe I can share those insights, and then I let the experts in the AI and cloud, take you for the rest of the 2 days. Is that all right? Okay. So 25 years ago, I was just sitting just like the way you guys are sitting here, with hope and dream in my eyes, because I had just graduated from my engineering, not far away from here, right across from CEG campus. So we were the sister concern. It used to be a joke in those days that CEG la ladies படிச்சு முடிச்சிட்டோம்னா IIT la பையனை கல்யாணம் பண்ணிக்கிட்டா life is settled. So we all used to come to the tea shop right across IIT to have tea, hoping that we will find some nice guy to get married to. Unfortunately or fortunately for the guy, that didn't happen. I went through a very simple arranged marriage in my life. But just to say, a women engineer, I was a mechanical engineer, by the way, was as my undergrad. 25 years ago, it was something that was not many women would opt for. And then I left to the US for my higher studies. And I was thinking, what is that I'm going to do with my life? So from professional side, like after I'm standing here, and if I can talk to you about some of the accomplishments and achievements that have helped me to reach where I am, I started as a developer community. So one of the things when Karthik came and spoke to me, I was very happy because I started as a developer, even though from a mechanical engineering degree. Going to the US opens up a wide arena of subjects that we could take. So I moved into, information systems that helped me to start the computer path. I worked in Sun Microsystems as a Java developer. Interestingly, 20 years later in GitHub, it is still one of the third populous language because of its robustness and versatility. So that was interesting to know that, I've started working in the language that is still be popular among the developers. And then I moved on to work on the Java Micro Edition, where the first Java went into the cell phones. I worked for Motorola for almost 10 years in the US. Enterprise, embedded system, and then once I finished my executive MBA, I decided to move into software strategy. That's what I did with Dell Computers, working right under the nose of Jeff Clark, the COO. In the meantime, I got married to a wonderful guy, 2 beautiful kids, and moved back to India with a long stint in the US for 22 years, just a few years ago. and I call Chennai my home. So here I am in IIT Madras, in front of you, sharing my life's journey, both personal as well as professional. So, but if you had asked me this question, or 25 varsham munnadi, the question if somebody had asked me, is this what you think your life charter is going to be? Is this what, I would have believed I would be? I don't think I would have agreed to it. I don't think I would have believed it. The reason is, we all stumble upon different things in our paths, thinking that this is the right thing, risk-taking. There are so many combinations, permutations are there that makes us what we are today. So if somebody had told me these 3 things that I want to share with you from my own experience, I am a person who believes in walk the talk. I think maybe few things could have been accelerated. I could have leapfrogged. Instead of waiting for 25 years to come and tell you this, I could have done this in 15 years, maybe, I do not know. But I still want to take this opportunity that is given to me by this team of organizers to share that insight with you. The first thing is, celebrate your success. I don't know if it's a cultural thing, because I kind of lived the American dream where you go in as a developer, then you make big, you buy a house, you buy a fancy car and all that stuff. But something about I don't know, it's the Indian culture or the Asian culture, we are always told that failure is okay, fail young, fail cheap, learn from your failures. I constantly hear that from, people here. So one of the things that my mentor in the US told me was, celebrate success, because what failure does is, it tells you what you cannot do. And it tells you the limits, but it never teaches you what you can do. But when you look at success from the other side, what success teaches you is, even it could be like a baby step towards your end goal. What it beautifully does it tells you what you can do and what you can actually continue to do in that path. So we all keep saying, last 10 years, Salman Khan's movie, everything is in the 100 crore club. Now it's not 100 crore, it's like 300 crore club. What is Karan Johar doing? It's just that simple formula that they would have figured out, that they keep continuously, just churning it again and again and again. And interestingly, whether it's Bollywood or Tollywood or something, few formulas like this in our own lives. I don't know what formula works for you, what formula works for me. It could be different for everybody because we are all extremely different individualistic person. But remember that, find out that formula and please just evolve on that. Keep working on that, because we don't have to go and reinvent the wheel. As developers, you are here, you're smart, you're intelligent. You're engineers or you may not be engineers, but whatever you are here today because you want to learn something from here, and there would be something that is key to your success and only you know about it. Please just continue to work on it, because that was one thing that for me, the success was, I'm going to be very transparent with you, was networking. Networking was the key for me to rise to where I am today. I keep very good relationship with my peers and also top up as well as the people who work with me. Working with the people that work with me should be always be, the comfort should be given that they can learn something from you. The peers should feel comfortable working with you, not as a competitor, but as collaborators. But the people who are on the top should be completely trust, and the loyalty built with them helps them to trust you to bring you to the higher level. So the promotions and everything, what it works, make sure your network is really, really good. So celebrate your success. Find what is that key that is in you that will make you successful. It would have happened to everybody here. So please, continue to just work on that. So that is one thing I really think, and also it is very true. And every single time it is 100%, slam dunk for us. For me, it has been every time. You go meet a meeting, you come back, you send an email saying thank you, blah, 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 and then you come home, and then you write to them, you keep their thing. Monthly once, twice a month, find a way to collaborate if you think that is valuable to your business or your career, and you will see that you'll go, great places. There's one of the key other things is that, the determination and the talent that you guys bringing. As I said, Kalela, from wherever you guys are, people have been flown in. That was Karthik told me. You've all flown in because you have the talent and the determination to learn something from this conference that's going to happen in the next 2 days, and you think that there should be some key takeaways for you. You are here for some purpose. There's some purpose there. So on the purpose layer, whoever is the people who are in and around you, who are in that, the community, please make sure that you find some kind of a collaboration with them. Like when I think Bhuvna, right? She told you, sis, look at the next person and say hello, even if you do not know that. That's all about networking. The moment you break that ice, I think it takes you to the next step. The other thing is, let me tell you about, one thing is, so success breeds success. Other thing is about creativity, risk-taking. I'll tell you a personal story myself. I think my husband lost his mother to stroke a few years ago. A wonderful lady, unfortunate. We couldn't do anything about it. And that's the reason why I had to move back to India to support the rest of the family. This led to something in him that they created a product using emerging technologies that stroke survivors, once they are gone, they're gone. We can't bring them back. But the stroke survivors can actually have a hope to live. And maybe their life will never return to normalcy because of, the physical aspects that gets deteriorated because of a stroke. But is there a hope to life, so that their self-esteem and respect for themselves can be done? So it's a completely social impact product that was created, which is in clinical trials and is already being, rolled out in different parts of the world. But what I'm saying is the key is to find a gap and have that passion to drive it to a solution. So since this is, I'm having a 1,000+ developer community with, super brains, this must be, put together. If you put all your brains together, the super processors will go for a churn, right? You guys are all so astounding here. But what is that each one of you can do for yourself is, please make sure the creativity in you is always there and you're always looking for problems when there is a gap, and if you can come with a solution to solve that. That's something that I've seen in the entrepreneurial journey, that I am personally not an entrepreneur, but I have been married to an entrepreneur for a long time to say that, is the passion to drive would definitely take you to that level. And each one of you, I'm sure there is a 10% or 15% entrepreneurial thing that is hidden in you. Again, as I said, coming from the developer community, all of you can, think of, questions and answers for many problems. So try to do a prototype, collaborate with your friends. If somebody is a computer engineer, somebody is a mechanical engineer, somebody an electrical engineer, maybe all this put together. That's one thing, like, when I read, about, Tesla, how this all came about. He knew, Elon Musk knew everything on different subjects. That's how he always able to put this all together. So please get into that collaborative and networking mode so that you can bring it all together. In fact, that, one thing for certain is to build value. So when I talk about these products, make sure that creating a bus is very easy. Again, I come from the government sector, so we sometimes debate whether quantity is important or quality is important. I re-emphasize, coming from a tech background, quality is extremely important. It could be that one single product that will create a quality and create value in the system. So when you are putting your problem statement or creating your business model, please make sure that there is a value that you're giving back to anybody. It could be a social impact value, or it could be a value that could be given to the society. It could be given to the developer community. It could be any value. But the value creation is the key to the success of many things that happens just on the schemes in the government also. Like, I had the opportunity to run as the Chief Strategic Officer of a skilling program called Naan Mudalvan. I don't know how many people have heard about this, where it is, and I created the blueprint that was rolled out in all of Tamil Nadu, where we gave microcredits to each and every government engineering colleges or government affiliated colleges under Anna University. 483 colleges, 17 lakh engineering and arts and science students are getting trained in all the latest emerging technologies as well as industry relevant courses, so that they could be industry ready, as well as we creating the skill registry for the industries. That is value creation. So when government is picking up these projects, they are very, very keen and as well as they're extremely focused on that approach that we are creating value for the society. So whatever products, whatever this you're going to be working on, or even if you're working for different companies like Microsoft or like Zoho or Flipkart, whatever it is, right? Please make sure you understand the big picture. Coming from strategy, I always tell my team, even if they are lowest in, like he could be an associate working for me, we always give the big picture so they know whatever they are working on is contributing to the success at the top. So creation of value is the second thing. Always remember when you're creating something. The last thing is whatever you do, please let it come from your heart. Coming from your heart doesn't necessarily mean it's going to be easy. It's definitely going to be tough because your heart says, you know what, getting out of the comfort zone. The reason I say this is it's easy for me to talk to you about this today, and because this is coming out of my own personal experience, regardless of what I am today. It took me so many years to make the jump to move back to India. 22 long years. And why is that? Have a cushy job, getting promotions every year, getting bonuses, living the American dream. Everybody I talk to is like, why go back, leaving all this comfort? So I think there was a life-changing event that happened finally where I said, as I said, I lost my mother-in-law, so I had to come, whatever had forced me to come. But I can't tell you that it has been the best decision I've made in life. It's moving back, coming back to our own country, working with the ecosystem, now working with the government for the past 2 years, coming as a professional, the kind of support that the bureaucrats have offered to professionals like us. So follow your heart. You will go through difficult times. Treading the waters is not easy. People will walk at you. Every friend in US mocks at me saying, how can you do this? But now after 5 years, they look at it, "Ella romba settled pol irukku, looking very happy. I wish we could have done that." So I think and you guys we were a brain drain people. We left and we are coming back, but you guys are right here. The amount of transformation you can bring into this economy, that too with Tamil Nadu means, and wherever you come from is tremendous. And India's wave, I work with PTR sir very closely, and he's a numbers guy, as you all know. He keeps talking about this is the curve. We are riding the wave right now. So the next 10 to 15 years is like a golden period, and I think we all should embrace that. So please follow your heart. Take the risks. Take small risks. Come work with us. I am the head of incubation for startup. You have a brilliant idea that you feel that you want to vet it out with somebody. I am also the CEO of IT&T Hub, which is a technology hub. Since you're all technologists, I'm opening up the forum for you guys. If there is you want to get incubated with us, come and work with me. We will do what as a government we can do and, evolve this community as well as help you guys out. I'm always looking for people to hire. I'm always looking for people to collaborate. I'm looking for consultants. I'm looking for ideas. I like to have community events where I want speakers so that, the rural as well as urban startup ecosystem gets, becomes thriving, because not everybody has the opportunity that you have sitting here, right here in IIT Madras. So the last concluding 1 minute I will tell you is, I promise you this, if you keep learning from your success, if you keep creating value, and you keep following your heart, your life will not only be long, but it will be rich, satisfying, and deeply rewarding. This is, again, whatever I said here is coming from my heart, because I've followed everything I told you guys, and I hope something will be a value add to your lives today after my talk. And anytime you need to work with me or come and, have to collaborate with me, my phone number, my email, everything is with Karthikeyan, as well as, my team is here. They won't agree. They have my cards. So I really appreciate the time you've given me. I don't want to take more time because I know there's lots of wonderful, real technology stuff is going to be spoken about. Thank you, and filled with gratitude that you took time to come here and hear me out. Thank you, guys, and wish you all the very best.
Wow, what a talk it was, right? Thank you so much, Ms. Vanita Venugopal, ma'am, for such an authentic and inspiring and insightful talk. And thank you so much from a Java developer like me. And also, thank you so much for offering to support the budding entrepreneurs and startups. Let's once again give it up for the inspiring keynote by Ms. Vanitha Venugopal, ma'am. Shall we? Thank you so much for taking time to be with us and for sharing your invaluable insights. And let's carry this enthusiasm generated by our insightful keynote throughout the rest of the conference. Next up, we have our silver partner, Zoho, and I immensely take pride in welcoming Ms. Rajalakshmi Srinivasan, Director of Product Management, Zoho, who is our consistent supporter, to give a talk on cloud observability and customer experience. Ms. Rajalakshmi is no new face. She is a globally recognized speaker known for her eloquence and expertise in addressing diverse topics and seamlessly navigating discussions on technology trends, motivating the youth and advocating the women empowerment. And she is truly a global speaker, and I take immense pleasure in welcoming her to the stage. Thank you, ma'am. The stage is all yours.
Good morning. Yes. Good morning, all of you. Yeah, I think low energy. But am I audible till the end? I don't know if the mic is properly working. Yes, no, no, yeah. Hello. Check. Yes. Yes. No. What do I do now? Wait. Can somebody help me with this? All right. Already we are running 15 minutes delay. And check. Yes, this is better. But I think I'll be restricted here because I have my laptop. Apologies for that. I was given 10 minutes, 10 to 15 minutes I was told. I'll try to restrict within that so that we'll continue with the session. So thank you so much for the introduction, and it's so great to see the full audience here and I was part of the event last year. So last year to this year, we could see the changes that has happened, and that's what we're going to learn throughout the session. So when we want to talk about, I just want to get back in history and start with industrial revolution. Just 10 minutes, I'll cover all these things in that. So if you talk about industrial revolution, I'll go back to Industry 1.0, which was in 1800s, where machinization started. So steam and wind and water was used as power, and that was called Industry 1.0. It was in 1800s. And then it took another 100 years, 1900s, for Industry 2.0, where we started using electricity, mass production, assembly line of things. So that was Industry 2.0. It took 100 years for that. And then for Industry 3.0, another 100 years, which was in 2000 time frame, where computers started picking up, and that was electronics and computers and automation. That was Industry 3.0. But if you see, Industry 4.0 was within the next 10 years. 2010, where the cloud and IoT devices. So the cloud transformed things that the technology change was called as another revolution by itself. That's Industry 4.0, which was in 2010s. And then now we are currently in Industry 5.0, which is in 2020s, within a span of another 10 years, The changes are so huge that we are calling this as an entire revolution. Personalization, AI. So if you see, this is how the whole transformation has happened. From 1800s to where we are today, what took 100 years for industry 1.0 to 3.0, the next two evolutions are happening within a span of 10 years. That's how technology is changing. We don't know what's going to be there coming up in another 10 years. So when such is the space, this conference is focused on cloud and AI, which was Industry 4.0 and 5.0. I don't know if they thought through this and came up with, but as I was preparing for the talk, I saw this aligned with that, so I thought I'll start with that. So these two are the topics for the next 2 days, cloud and AI. So I'll give some brief on what is that. We'll just focus on these two alone. For cloud, so when we read through, when I was preparing and I was going through some articles, what are some of the potentials that are available in the market for these industries? So there is this business research company article that talks about the infrastructure as a service market size and growth, which talks about in 2022, what was 81 billion transformed to the compound annual growth rate with 19.4% in 2023. We have 96.93 billion IAS opportunity, market size. And the size, and if you extend it to by 2027, the growth is expected to be again at the same pace of 18.2%, and 189 billion market size is what is available. So the market potential is huge. How much are we able to grab or tap it and use it in our business is what is important. And if you see within India, okay, you are talking about the global infrastructure market. What is that potential that is available in India? NASSCOM has come up with a report. What are some of the opportunities for India with respect to cloud, and what is the economic impact it's going to have? Within the Indian market itself, 53% of enterprises have increased their cloud adoption over the last 1 year. And 84% of large organizations are adopting SaaS, software as a service. SaaS is something that started 15 years ago, but larger enterprises are starting to use that. And by 2026, 8% relative share of India's GDP will be through these cloud adoptions. This is a NASSCOM report which I was reading through recently. And it's going to create more jobs. 14 million jobs will be newly created. Because a lot of time, we hear the opening keynote speaker also talk about there is fear. The AI is replacing jobs. No, there's going to be more jobs that are going to be there. So when we talk about cloud and the components that are there, we were talking about infrastructure as a service, platform as a service, software as a service, but it goes beyond that. AI as a service is something people are working on. Machine language as a service is something people are working on. If you don't have all the algorithms, you can make use of the service. It's almost like XAAS, anything as a service. The cloud has transformed to such a pace that you can look for device or data or anything as a service is the model that the people are working on. And it's not just in one industry. You take any industry around us. It could be retail or media or finance, healthcare, education, IT itself. Every industry has been touched or has been revolving continuously or transforming because of this cloud adoption. So when every industry is going through cloud adoption, what are some of the challenges? There are many challenges. I'm just listing the top 3 challenges. Of course, availability. That's the primary challenge. We want all the components to be up and running. Be it when you're taking it to the cloud, to the SaaS world, everything has to be up and running. The downtime could be anywhere. It could be in your website or application or infrastructure or network or the platform. If there is a problem in one place, it's going to bring down your system. And companies are looking for, or industries are looking for 99.999% available. 5 nines. It's not 3 nines. That's what is the primary challenge. And it's not in any order, but the next challenge is performance, speed. All of us use mobile phones or through web browsing. Something doesn't work, the internet is not working within this hall. You go outside only, you'll get network. But what we do in our office, we continuously keep refreshing. None of us have the patience or time. That's the pace we are in. So when your components are not performing, it's going to create problem. Slow is the new down has been the slogan which I've been talking about for the past 5 years, because that is the fast internet space that we are living in. And the third component, of course, security. I want to stress a little bit on security because that's a crucial thing which a lot of us miss on. With respect to security, there are three important things. We can have a separate session if we want, but the three important things that I want to share is we have to make sure, I'm sure this is a developer community. Most of you would have been developers or aspiring to be developers in different roles. When you move to the cloud, across the different layers, you have to take care of security at all layers. It's not important that you take care of it only at the application. If there is a problem in the infrastructure, from your physical security to your configurations, to your IAM management, identity management, data classification, how you do at the end user layer. So across all the layers, security has to be taken care. That's an important thing when you move to the cloud. The second thing is zero trust. Of course, people we need to trust. But with system, when you have it in the cloud, make sure you have all your data, devices, networks, applications, audits in place so that you ensure zero trust and there are no vulnerabilities in your system. Third important thing is shared responsibility. A lot of us miss on this. It's not that you take care to make sure that your entire system is secure. But if your customer who's using the system is sharing the credentials, then it's not you can't do anything about it. So you have to be clear about what is your responsibility versus what is your customer's responsibility when you are in the cloud. That too in the different layers of cloud. If everything is on-prem, what are your responsibility? If it is an infrastructure as a service you are using, what is your responsibility and what is your customers? For platform, for software, you need to know these things. So these three aspects I want to stress on security because that's crucial in our current world that we are living. So that's about the cloud part. I'm just giving the top aspects of what we need. And the Industry 5.0, which is AI, if we have to move to AI, that's personalization. We are all living in this era of citizen coders where we don't want to take what is available and use it. We want to add our own customization or bring in personalization. I will do my own client, drag and drop. So in such places, customer experience plays a major role. So digital, whatever product you are in, whatever work you are doing, make sure you take care of customer experience. And when we talk about customer experience, particularly in the digital world, there are a lot of things to do. It could be in the way how you customize your client, or it could be in the way how you pick a phone call and talk to your customer. It could be in the way of adding value to your products and giving away quality products. There are n number of things to take care when you talk about experience. But keep in mind, it's a great differentiator because there is so much competition. The main differentiator could be the experience that you're giving. Even though there are problems in your setup, people will be okay because we are all human beings at the end of the day. So differentiate your product by means of customer experience, for which you will need monitoring. And if I have to say, this AI personalization has changed this monitoring space to observability platform. So if I have to give one line of differentiation, monitoring will be for your entire infrastructure or your components platform. You take care of some fixed metrics that you do. That's monitoring. But today, the unknown, undefined platform or the structure has to be taken care, and that is the observability platform. And I'm sure those who are aware of observability, you know that these are the three pillars, which are metrics, traces, logs. I'll just mention that and finish it off. You need to take care that you collect all this in your platform using the right observability platform when you take care of AI. So these two are the major components, which is cloud, which is Industry 4.0, and AI personalization, which is Industry 5.0. I'm sure we'll be listening these two topics the entire 2 days. Like you, I'm also interested in learning from industry experts because this is applicable in each of the industries, and we have sessions for each of the industries. So there is so much to learn across the 2 days in these two aspects. Let's learn and apply it in whatever we do. Okay? Thank you so much for your time.
Let's once again give it up for Ms. Rajalakshmi. Please do visit Zoho booth that's right outside this conference during your break time. And with that, the unified sessions that are happening on this track is going to end, but please don't go away. We have some crucial instructions to give you. So, we have some crucial instructions. From now on, there will be 5 different separate tracks that will happen. And the coffee break today, for today alone, there will be a coffee break. You can grab your coffee in between your sessions at 6th floor on the building by 11:15. So you can go to the, after we leave you in 10 minutes, you can go to the track of your interest and then start the, and then come back and grab your coffee on the 6th floor. I would like to quickly tell you where the tracks are happening. Here, the track 1 will happen here on the same Audi, and track 2 will happen at the amphitheater that's right outside. And track 3, 4 and 5 will happen in the building E that is opposite to this. So track 3, 4, 5 is on the ground floor of the E block. Please make a note of that. And I believe you all have your agenda flyers with you, right? And mainly track 1 and 2 will be on AI. 3, 4, 5 is the mix of data, developer and all that. And I would like to request the audience to be as engaging and energetic as possible. Let's hear it for the AZConf. Come on, make some noise. Some more. I have been hearing Chennai audience is not making enough noise. Can you hear it for Chennai once again? Woo! Wow, that's the energy we need. You have 2 long days and lot of insightful talks and all that. So don't let your energy go down. We have been having some energetic keynotes and talks here already. So don't let it go down. Please, you have paid, everyone has paid at least $1,000 to be here. Make use of that, exploit the whole experience we have for you here. And whoever is going, go to your track, and the coffee break will be only at, can I request you all to stay for the main code of conduct? And then you can leave. The session starts only at 11. So you can be here for some time. The main housekeeping, lunch and refreshments will be served in D block 6th floor. So the 15 minutes that we have lost here would be accommodated. And again, lunch and refreshments are only on D block 6th floor. You would have to come here to have that. And washrooms are available in whichever floor you are. Please make use of that. And then mobile phones, please, you know that please keep it on silent so that everyone enjoys this experience. And please be on time for all the sessions. You can please network with everyone, but during the break time, and please make sure you are on time for the sessions that is of your interest. And there is Wi-Fi available, and you can make use of that. It's on the whatever track you are attending. There are Wi-Fi instructions there. Code of conduct: be considerate, kind, constructive and helpful. Treat everyone with respect and dignity. Be mindful of your surroundings and fellow participants. Refrain from demeaning, discriminatory or harassing behavior and speech. If you are not sure, ask someone instead of assuming. We have volunteers everywhere. Most of them are wearing black t-shirts. You can, in each and every track there are multiple volunteers and MCs. Please go ask them if you have any questions. And if you face anything, alert organizers if you notice a dangerous situation or someone is in distress. And please let's all be considerate and sustainable. Please use dustbin everywhere to dispose of waste. Kindly avoid causing any damages to the event property in any way. Please check the signboards to actively participate in any track. For any queries, please contact the desk or volunteers. And please be mindful of your belongings. Please keep your belongings safe. I know many of you would have carried your laptops with you. Please keep them safe, and it's your responsibility. And last but not the least, we have the photos that are taken in the conference. You can, these QR codes will be available. You can scan the QR code and register yourself, and you can find your photos directly by scanning the QR code. I'll leave it here. And other than this, again, I'm going to share two things for the audience. One, network. Please, you won't get a chance like this again. A huge, diverse range of technical enthusiasts we have here, from learners, experts, everyone. Network and make use of that. Two, let us make some noise online. Please do share. It's not okay to be silent. You have got this incredible opportunity to be here. So let's make some noise. Let good say make some noise. Okay? So share it on social media in any way you can. Post as much as possible. This is not for yourself. You are growing a community. You are not just promoting yourself. You are promoting the whole idea of this community-driven conference. How awesome it is, right? Let's all support some community and make this event even more bigger next time. Shall we? I say AC Conf, you say Chennai, okay? AC Conf. Once again, AC Conf. More energy, AC Conf. AC Conf. Innapa. You know, one time, 2 times, okay? AC Conf. AC Conf. Woo! That's the energy we need. And with this energy, let's carry forward the 2 days. And I'm reminding whoever does most number of votes will get goodies from us. And to speakers, I wish you all the best for your presentation. And I pray to demo gods that they are by your side when you do the demos. And any other instructions you want me to give?
Keep your valuables safe, because there were last year there were some instances. So keep your mobile, wallet, bags safe with you all through the day.
Session start at 11 o'clock sharp on all the tracks. 11 o'clock. You can grab your coffee at 11:15 or so. Whenever you find time, you can come and grab the coffee and refreshments on the D block 6th floor.
Hello. Hello.
Hello, everybody. I think, you all can occupy the first rows, so it'll be better. We'll get started in just 2 minutes. We all can wait just, for 2 more minutes, and we can get started as people are just coming in. Meanwhile, you all can, click pictures and post in Instagram, Twitter, and, your social handles and tag AZConf. So hello everybody, I'm Heva Priya. I'll be the moderator and MC for track 1 for the day. So I hope you all would have, looked into the agenda of what track 1 is, and then, you would have come to track 1, right? So how many of you are excited for a particular topic or talk? Anything in specific you have? Yes, no, maybe? So now that you're in track 1, I hope that everybody is into Gen AI and, cloud, right? Yes, all right. So I think we'll go ahead and get started with our, first speaker for the day. We have Rakesh Raburi. He is the engineering leader and CTO at Publicis Sapient. And he is going to give a talk. I mean, the topic was really exciting for me, and I'm looking forward to his talk as well. So he's going to present his topic about the evolution of cloud native architecture and how it has been transformed with Gen AI. Yes, some noise, sound, clap, something. Yeah, so I think he is going to help us decipher the evolutionary code that propels the cloud native architecture into the future, with the special role of how Gen AI is transforming the cloud architecture. So I think, it's high time to give it over to him. I think Rakesh, you can take over the stage.
Thank you. How is everyone doing today? Good? Yeah, today I just got down from my flight and I was coming here and I was thinking about, okay, what is common between me and the audience out here for this talk? Any guesses? Knows about it. So Publicis is one of the world's largest media and content firm. So almost all the ads which you see globally must have been distributed by Publicis. Whatever your ads you are seeing during the World Cup, they must have been, distributed by Publicis. And Publicis Sapient is the digital transformation company arm of Publicis. So what we do is we help clients, like Fortune 50 clients, help in their e-commerce business to transform themselves from a what we call it as end-ups, not startups. End-ups, the startup becomes an end-up, and then they have to transform themselves to compete with startups. So how do they do it? Generally by technology transformation, business transformation, experience transformation. So these are all some of the things which we work, and cloud is one of the transformation which every company is doing right now. So my talk is about what transformations are we going to see this? Cloud is already old. So cloud native is an old architecture. We need to go to the next, and which is, all of you know what is it, is Gen AI. So let us just look at what is happening. So I want to start with this frame. So most of you in this audience, by looking at your age, I can say that you all must have joined around this time in the IT industry. Anyone joined before that? Me. I'm the only one who joined before this. Okay. Oh, there's one more person. Thank you. There's one more. Okay. So in 2003, it is virtually the time when, even if you see, I grew up in a place very close to Chennai, actually 80 kilometers from here. My father used to work in ISRO. So all 20 years of my life I was here at ISRO. So I used to come to Chennai a lot. Chennai was not like anything related to technology, right? It was like all manufacturing. It was all old economy at that time. So only after 2000 or something, the IT industry started picking up, right? Like the IT park started opening up, right? In late 90s, early 2000. The reason for that is this. The companies of the world, the big companies of the world, basically said that you should not be wasting your time doing IT, outsource it, right? Find the cheapest provider in the world and outsource this. And where did they have the most lowest salaries in the world? India. So that's why they came. That's why our salaries still didn't improve. But that is good. Whatever reason they came here, now they realize that we have the talent too. It's not just about the cost arbitrage. It is changing. But that was the idea, right? Like everyone thought about that, and that is the reason why the software industry started in India. All of you know about this. Next, what happened is exactly 10 years after that, right? What do you remember about early 2010 and 2011, right? A lot of startups started coming in, right? Flipkarts, Amazon started coming in India, Google started coming in India, Microsoft was growing in India, right? All the big players came to India. Lots of other companies started realizing that, look, if IT is outsourced, we are not a force to reckon with. The biggest companies at that time, like Amazon was just becoming a big giant in 2010, realized that we are a technology company. They started proudly calling themselves technology companies. Earlier, no one wanted to call themselves technology companies. They used to say, we are doing this business. Yes, we do IT efficiently. That is what they used to say. But from 2010, the narrative changed. Everyone claimed that they are a technology company. If there's a startup, the startup says that we are a technology company, which we do this, right? Technology became the core of any company. If they don't do technology, you are not a big company, right? So from 2010 to 2020, if you see, all the Fortune 50 companies or the Fortune 10 companies, the biggest companies, the top 5 companies, they're all technology companies like Amazon, Facebook, Google, Microsoft. These are all technology companies, right? You don't call them like traditional businesses. Technology basically set the stage, right? Then another 10 years, 2023, what happened? All of you are hearing, you heard like a couple of keynotes. All of you must have heard the things about AI, generative AI and everything like that. So this is the era of AI. But AI has been there forever, right? When was the first neural network written? Anyone knows the answer? When was the first neural network code written? Any guesses? 1940, yeah. Code only was not there, man. 70s. Any other guess? Okay, 1956. The term of neural network, or it was called perceptron, was created in 1956, right? It was there everywhere, right? Like what we are using right now, the essential base architecture of generative AI, which is the ChatGPT and all those things are based on, was there from 80s. My MS thesis was on neural networks back in 98. And people told me, you will not get a job, man. Why are you doing this? This is a research topic. Right? That was my thesis in 98 in my master's. Right? But what has changed? What has changed that it became viable right now? Any guesses? Compute, cloud. More than compute, it is cloud. Right? The processors have stagnated after 2012. Really, they have not grown in compute size. But what happened? More processors at the same place happened, right? And what made them come together? Cloud. So this conference, when we are talking about cloud and AI, it's like the perfect storm. And this reminds me exactly 40 years back, Chennai had the perfect storm. If anyone remembers, anyone was born at that time. Chennai had the biggest storm because I remember when I was in my 3rd class at that time. And I was so scared. The eye of the storm passed here. The winds were 200 miles per hour, right? Can you believe it? 200 miles per hour. There was nothing left. There's not a single tree left. Like everything was wiped clean, right? It was 83, I think, 83, 84, something like that. It was called the storm of the century. Now, why am I bringing it up? Now is the perfect storm of compute, technology, and everything coming together, right? What else is coming together? 5G, right? Why is 5G important? See, if you can have compute somewhere and if you can't reach it fast enough, there is no use, right? 5G enables you to sort of run something on the cloud and with minimum latency, you can still access it, right? So in your phone, when you're typing something and the ChatGPT is typing as it is getting rendered, the reason why it is happening is because of the networking and all the things which are happening. Now, what does AI require? What is the fuel for AI? Data, right? Now, I put something called IoT and what you can say, edge systems. These are really important because the edge systems and IoT collect the data, right? They collect about everything. Data about like the temperature, the data about what is happening in the traffic, the data about whether it is going to rain or not, the data about all kinds of data which will be there. And that will make the system more intelligent. The more data you collect, like how many people are coming here, who is walking here, like who is paying attention, who is not paying attention, every single face is being recognized, right? What is happening in the world? All this data makes the system intelligent. So you feed it data, the intelligence increases, right? Or what we think is intelligent, because that is the next part. What we think of intelligence is right now is, oh, it knows things, so it is intelligent. We are now starting to question that. Is it knowing things is intelligent or something else? Because we need to create a job for ourselves, right? So if knowing things, now ChatGPT knows more than all of us, right? Because it has read every single book, it has read every single article on the internet, so you can't compete with it. So how can you compete? We'll talk about that. So all this is happening, right? So if you see the articles, everyone is talking about what ChatGPT is doing, every single article, no matter what it is, right? So we all need to talk about generative AI. 6 years ago, anyone knows this person? Andrew Yang, great. So all of you know about this professor of AI, right? He's became famous because he teaches in a way that most of us understand. So there's a huge fan following for him. If you don't know him, please look up Andrew NG. There's a lot of free courses he has. Very good introduction to generative AI and AI. So do it. 6 years ago, he made this statement saying that anything which can be done with 1 second of thought will be automated. So what used to be done in 1 second of thought, some examples I give you, is like translate between Tamil and English, right? Now, if you know both the languages, within 1 second, you can easily translate, right? That is what humans used to do. And now we have like phones, we have like the Google Translates, they can do it on the fly very easily, right? Like now translating is an easy option, and real-time translation happens while you're there on the Zoom call. You can set up like translation in different languages. It is happening at real time, not even after the call recorded thing translation. Now that is possible right now. So anyone knows when Google Translate came? Any guesses? No. It was 2007, right? So from 2007, we had the state-of-the-art AI. So what has changed now? The biggest change, what is happening is, what is the difference between AI and Gen AI? Any guesses? Data architecture, data size and architecture. But one creates data, generates data, another, but Google Translate is also generating data, right? It has been trained on data and generates data, but AI that doesn't generate data. Okay. No, traditional AI also doesn't create history. History is used only for training. After that, it has to predict. Okay, the biggest difference is AI, when we say AI in the past, right? Like, it's not the definition of AI. The AI, how it was, we talked about is, it is single purpose. If you train a model to translate, it can just translate. If you train a model to recognize your face, it can just recognize a face. It can't recognize a fingerprint, right? If you train, so there are models for specific things, for specific tasks. Each task had a model. The difference with generative AI, Gen AI is one thing it generates. That is how it started as generative AI, but that is also a misnomer because earlier AI is also used to generate because whatever output it's generating is generated only, right? The only difference is it is able to generate different things than what it was intended. That was the difference, right? And the generation thing, they added steps to decoders and encoders, which makes it easier to take an image, generate an image, take a text and generate an image, take an image and generate a text, or take a video and generate a text, like that. So they're able to do lots of other combinations. So generative AI became more versatile. The biggest difference is versatility. Versatility of even the people who created it didn't predict it, right? They didn't expect it to, when they taught it English, to answer in Bengali. Did you know about this? They never trained it on Bengali, but it was able to answer in Bengali. How? Did you guys hear about this? That is what scared people actually. When the first time when they did it, they trained all of this and it was getting better and better. One random night, one of the researchers said that, okay, let me ask a question in Bengali, right? It answered in Bengali. And they were like, how did it know? Because we never trained it on Bengali. How did it answer? No, but it didn't, it is not trained on Bengali. How does it know what next word in Bengali comes? If you never heard about Tamil and suddenly you say a Tamil word, what will people say? You are God. No, I'll tell you, now people still don't know what it is, but there are a lot of theories on how it did. I'll just introduce this. So this is what happened, right? Like, so earlier models they were training, each one was being trained on a particular aspect. But as the number of parameters increased, what are parameters? Parameters are nothing but connections between individual nodes in a neural network. If you know neural network is nothing but a graph, right? There's a node, it connects to multiple graphs, and then there's a simple linear equation between one graph and another graph. That's what they do. As they started adding more and more nodes, it started making connections which is not visible to you and me because we are not thinking hard enough. It was able to do hidden connections which we were not able to create, and that looks like magic to us, right? You ask ChatGPT, write a poem about AI, it writes, but it never read a poem about AI. But how is it able to write? It is able to connect between poems, AI, and some rhyming words. All these three are three different parameters. Earlier you used to have a model for rhyming parameters, model for poem structure, model for AI words. It is able to generate all of these three and say that, okay, fine, I can connect all of these things and make some connection. Now, that hidden connection we are forgetting. Now I'll come back to my language example which I made. All languages must have derived from a root language, right? Right? Let us take India for example, right? Like most of the Indian languages, they all have connections in Sanskrit or something, right? So there are a lot of Sanskrit words in most of the Indian languages. I know this is a long statement to make in Tamil, but I also believe Tamil has a lot of Sanskrit words. So they all are like, once upon a time, humans community used to be small. So somewhere it must have started, right? From a small community, we all spread and different languages got created. AI was able to see this hidden connection between Bengali and English. For us, it is not obvious, but they are still connected. And it is able to make that connection. That is why it was able to do. Right? So same way, that is an explanation now we are creating and we are putting it into it. But it is true because now you can see, right? When you give it an image of something like that, it can generate another image, right? So how is it able to do is because it has created this tree of knowledge. It has seen every single book which no human can read, right? Like I was seeing the other day a graph. A human must have read, let us say, 100,000 books in his lifetime. AI has read 100 million. Right? Every single thing which is ever written, GPT-5 is trained on every single thing which has ever been written. Right? And the newer models are being trained at real time. They are getting trained on the text which AI is generating to refeed it again. Right? So it is reading way more than whatever we can imagine. So imagine the connections it is going to generate. Now, why am I saying all of these things, right? These are all the introductions to what we need to do next. We need to evolve. We need to evolve, not as into androids, that might happen, but we need to evolve our thinking, right? We need to think differently, because now our computers are no longer restricted by what they can do, but what we challenge them to do. Earlier it used to be always about the computer. We always used to talk about restrictions of what a software package or a program cannot do. Now it is all about what can't it do, right? So in order to do this, we need to evolve our thinking on our architecture, how we are going to sort of do. I'm going to come to the main topic for this. So how many of you have ideas in this room? There are a few people who don't have ideas. I can't believe it. Right? Every one of us has ideas, right? Every day we come up with a new idea, right? Why don't we do it? Why don't we take every idea and make it real? Why don't we take every idea and make a app or a software package or a new business? Why are we not doing it? The first reason why we don't do it is we don't have the resources. Right? You can have idea, right? But if you don't have the raw material to do it, you don't have a factory to do it, how will you do it? Right? Ideas itself is not enough, right? After ideas, the first thing you'll ask is, I want money, why do you want money? Money is not required. The money is required for resources. Right? Resources are the raw materials. And then what else do you need? If you have money and resources, is that enough? You have the ideas, and I'll give you whatever you want. Can it still be done? Oh, sorry, what? No, mindset is ideas, right? You have ideas. You have resources also I gave you. Can you still do it? You need a market. I just said do it. I didn't say sell it. Huh? No, cost, effort and cost, all the resources. Time, effort, cost, everything is resources. Feedback. No, you don't need feedback. I just asked whether you can do it or not. Yes, someone answered it. You need skills. I can just give you a bunch of iron and then I say make a hammer, right? You have an idea to make a hammer. Can you do it? No. Unless you are a blacksmith, can you do it? You can't do it. You need the skills in order to make it. The reason why I put this slide is, just now you answered, all of you have ideas, right? Now resources have become cheaper and easier to get. What do I mean by that? Just to go back to my example of when I first wanted to do a website back in 97, 98 time frame. How difficult was to create a website? What did I require to create a website? I'll tell you one thing which you'll never guess. Like the first thing which I needed to create a website was a network crimper. Because I had to take a network cable, pull out the cables, put the thing. Do you know what network crimping is, by the way? How many of you have done it? Yeah, so there are few people, old people like me. Okay. So that was the challenge, right? You need to have a network crimper, then you need to configure your router, then you need to get a connection, internet connection, and then you need to have a server. In that server you install, that time there was no web server also, right? Like they used to run a program which sort of is continuously running and listening to a socket to listen to a request and then respond in the format which is required, right? Just to create one website, it took us more than 2 months, right? 2 months to just create a simple website. Now if I ask you to create a website, my daughter who studies in 3rd class can create it, right? Creating a free website is nothing, so easy. She'll create one page, she'll even do the design, she'll actually put some nice graphics, she'll take some photographs and take her own photos, she'll create the whole thing, and she does it in 10 minutes, right? So resources have become cheap. In cloud, you know, if you want to write an app, what does it cost you? Nothing, right? Most of the websites and this one, until you have 100,000 users, it's free, right? You have free tires in cloud. Resources are free, right? You can do whatever you want, right? So what is stopping you, right? Ideas are there, resources are there. What is stopping you is the skills, right? You want to do it, but like, oh, I need to now learn this framework if I want to write a mobile application. I want to now learn how to deploy a Docker container using Terraform. I don't know that. I have a cloud free tier, but I don't have the skills to deploy it, right? That was what's stopping you. But now that barrier is also gone. Go to ChatGPT and say, write a Terraform script to create an EC2 server and deploy a Docker container, you're done. You got that too, right? Ilyas was talking about, go to the, what you can say, ChatGPT and say, okay, now create this HTML app in React code and do this. With the latest ChatGPT announcement, which you saw 2 days back, it will create a project structure also. It will create everything for you. So you have the skills now. You have every skill, right from DevOps to developer to front end to back end to database. It can even write the GenAI transformer code for you. You can become a data scientist today. Only thing which stops you is you don't have the data to train it, right? But you can do that. Even the data is available. You can download it, right? Like all the data which is trained, GPT-4 is trained on is downloadable on a 5 terabyte disk, which is this size, right? That's all it is. So, but is this enough? Now that you have all three, now all of you are now entrepreneurs and all of you can create resources. What is stopping you? No one is trying to make an attempt. Market and no, I didn't care about whether people use it or not, man. I just wanted to get done. Knowledge to use it. No, what requires is, yeah, you need a market, you need all these things. The question is it something which people want, right? Is it something which people want, or is it something which actually solves a problem, right? Is it something which solves a problem? Is it something which market, if it solves a problem, people will want it, right? And how you solve the problem is also important, right? It is not just about solving a problem, it is how do you solve it. So what I feel is, the one thing in this room, if all of you want jobs going forward, since all the other three are available, if you are not creative about how you create solutions, you will not have a job. So you will not, it is not, until now, you all relied very confidently, very safely, I'll say, 95% of the people in this room relied because you have skills. That's the only reason why you have a job. Right? People gave you ideas, people gave you resources, and they got you, they gave you a job because you have the skills. Now if the skills are getting automated, or if the skills become boring, as someone, as Ilyas was talking about how Satya told, like all the boring job. Like now writing a simple code is a boring job because it can be generated. Right? So people will ask you, why should I value you? Why should I pay you so much to do the same thing? You will still have a job, but you will be paid a lot lesser. The only way you can sort of do what you can say, create value for yourself or compete with machines is by being creative. The reason why I'm saying, people will say, the moment I say creative, they'll say, oh, no. ChatGPT is creative right now, right? Like, I'll see all the image generations, what images they generate. Just generating is not creative. ChatGPT and all can generate code based on the code it has trained, right? It can never creatively come up with a new way of doing a code which it has never been trained on. What I mean to say is it can assemble pieces in some order to sort of create it. Creativity is way more than that, right? Until the time when, I don't know whether you guys have all seen, there was a painter called Dali. How many of you know? He does the most craziest of the painting, right? He has like clocks which are melting, which is one of his famous thing. Now, that is his idea, right? Now, AI can create a clock which is melting if you tell it to, but someone has to come up with that idea, right? I want an image with the clocks melting. That is creativity, right? AI will never, you will say, generate me an image. It will never come up with that image of clocks melting and say, this must be what you like. No, it will never do that. It will follow what you are told based on what is melting mean, what does clock mean, and it will do that, right? So, the creativity, now, why is it important, right? I'm not talking about artists. We are all developers here. We are all programmers. We need to think creatively about how to do applications. Yes, it can generate an application, but it will generate an application the same way as what it is generated today, right? The same project structure, the same things. That will not be good for you for tomorrow. The same architecture it will generate, which will not be enough for you tomorrow. You need to come up with new architectures. You need to think creatively about your architectures, and that is what I'm going to talk about in the rest of the stuff. So before I talk into that, before I go into the architecture, there are certain fundamentals which I want you to sort of think about, right? So we at Publicis Sapient looked at it. See, generative AI is like fire, right? When early caveman first saw the fire, it was impressive, right? He knew that it can scare the animals. He knew that he can use it to burn his enemy's house down. He knew that he can use that to cook. He knew that he can use it to, melt something. But he knew the power, but they couldn't do anything about it. Why? Because they needed to create some structure around it, right? You can't handle fire in your hand, right? People had to discover various ways of handling fire, carrying fire. Earlier, what used to happen is, when they discovered fire for the first time, they never used to put it off, because they never knew how to start it again, right? The same way, the generative AI right now is in that fire stage. We all know that it's very powerful, but we don't know how to use it. So we need some structure in sort of doing this. And the very first structure which we want is ethics. The reason why I took the fire example is this, right? Yes, fire is very useful, but the very first use of fire, if you take to burn your enemy down, that is not ethical, right? So you need to create a framework of ethics saying that what are you using this generative AI for, right? So start with ethics, then comes governance. Now what is governance? Governance is, okay, I'll not burn my enemies down, I'll burn the animals, right? Now people are saying, yes, you need to burn the animals if you want to eat them, that's fine. But you can't burn all the animals. If you burn all the animals, next season there'll be no animals, right? So that is where the governance comes, right? You need to sort of control what you're doing. Yes, you're doing it, but there should be a control saying that, okay, you don't want to burn maybe the next generation of animals. You might want to burn the old animals, right? That will not affect the population, right? Some kind of, I'm just taking this crude example so that it becomes easier to understand. So we need to have some governance on where it is used. Not everything is bad, but overusage is bad, underusage is bad, right usage is what governance and risk frameworks comes in. So you need to understand that. Next comes is, there needs to be some motivation for why we are doing that. I will come to this part. That will be the most of my talk about. And then you need to have the right enablers, right? Which is basically the data, tooling, and all those things. But the most important thing is these parts. We tried to sort of group, when I say drivers are the motivation for change. If anything has to change, the first question you should ask is, why should it change? Right? What is the forces acting on a system to make it change? Right? So these are some of the forces which are acting it to change. I will explain once I started giving more detailed about this. Now, the very first thing what everyone is doing is, you've already seen a lot of articles. Oh, now if GenAI can generate code, why are you taking 1 week to do this? Right? Or why do you need 10 developers to do this? Right? It can be done faster. Right? That is the immediate thing which comes to everyone's mind. Right? So, and we sort of put saying that, okay, you can use it to increase efficiency. You can increase it to sort of reduce the normal activities of what we do. But if that is the only thing which you do, what will happen is you will make a faster caterpillar. You will never become a butterfly. You understand the difference? If you are using generative AI to only increase the speed of what you are currently doing, not doing something different, all you are doing is making faster caterpillars. Right? You are not transforming. And going back to the core of what we believe at Publicis Sapient is transformation is the key. It is not about just doing brute force or just doing the same thing again and again. You need to transform to do something different. You need to transform to get different outcomes. You need to sort of evolve your architecture, evolve your business processes, evolve your experience so that you do better value for the customers at the end, right? So same thing. If people ask our clients and partners come and ask us saying that, okay, use GenAI to increase the speed. My question is, yes, we can increase the speed, but increasing the speed to do what? You need to have ambition to do more, right? Because if you just make it faster, your competitors will do something better, right? Just to give an example, I'll just, as I go into the example, I'll give it to you. So the question is, how do we do it, right? Now you all understood the concept. It is powerful. It is going to change our world, and we need to do something different. Now, if you want to do something different, you can't continue doing the same things, right? Faster, right? We need to sort of change. So I want to talk today about evolving your architecture. But before evolving the architecture, I want to just very quickly go on what the architecture is about. Everyone knows this diagram? Yes? Do you know where I took this diagram from? From my daughter's 3rd grade computer science book. It says this is the computer architecture. And it's correct. That is what it is. That's all we do. Right? Now, what is changing in this, right? So you have input, output, then you have certain rules, right? That rules will basically, let me go back. Yeah. So rules are nothing but saying that, okay, how the processing should happen, right? When I say input, processing, and output, how the processing should happen is your rules, code, right? Code basically tells you, if the input is this, do this. If the input is that, do this. If the input is 2 numbers, add them. If the input is 2 numbers and a multiplication sign, multiply them, right? That is rules. Context of the memory is remembering what has happened so that like you don't have to give too much of input. The only reason why context or memory exists is so that the input doesn't become larger. You tell, okay, refer to the memory. I don't have to tell you every time. So this is how generally every one of us work, and computers also work. Now, what has changed with the ML architecture? When ML architecture is the machine learning architecture. The moment machine learning architecture happened, we sort of reversed the procedure. The memory became data, right? Now, the data was trained using processing to generate the rules, which is the model. Sorry, I don't know why it is So, with ML architecture, this is what exactly happened, right? We took the thing, just changed it a little bit, saying that, okay, we'll take whatever data is being generated, we'll put it in the reverse cycle, we will use the processing to train, to determine what the rule should be, right? And once we did this, what we got was the input became intent. Now, this is a very important thing to realize. The reason why people like ChatGPT was, right, because it understood the intent of the user in natural language. It was doing the same thing what like 20 tools from Google were doing the same thing, right? Like translate plus word prediction to the next thing plus calculation, right? Google had like 3 or 4 tools which are doing all the same things, right? But you had to understand saying that, okay, you take the output from one thing, then put it as an input to another one, then take the thing and tell exactly what you needed to do, and then it is going to sort of do it in a cycle, right? Now, with the natural languages, the input became intent and the output became possibilities. There's no longer exact thing. It just gives you text. You need to understand what it is. Or it basically gives you a JSON thing, and you need to understand what you needed to do. It gives you multiple outputs, not single output. It will give you multiple outputs, and you can regenerate it multiple times and do all those things. So if you talk about how a cloud native architecture is, generally it is made up of these 4 parts, right? You have a databases or a system of record. You fetch the data, you aggregate it using your microservices or your what you can say application components, and then you sort of render it in your UI. Then you take the input, right, which is whatever the user is providing, you validate it, and then you store and forward it. Essentially, this is what all of us do, right? No matter what names you call it, at the end of the day, every system can be reduced to this. You can do it sync, async, all kinds of fancy things, but this is what you do, right? You take some data, you aggregate it, you show it to the user, you take the data from the user, validate it, and store it, right? That's what you're doing it. Now with the generative AI things which I talked about, these are the things which happens. These are the additional steps which started happening. Between the aggregate and render, you have a generative part of it. Now, how is this happening, right? All of you must have seen some of the examples in Amazon and other things. When you have reviews, you can read all the reviews. You can read 100 reviews to figure out what the users are saying. Or you can have a generated content which says that, oh, these 100 reviews are talking that this product is easy to use. These 100 reviews are talking about they have good colors in this product. These 100 reviews are talking about. How does it do? It summarizes them, right? The same thing. You can take the 100 reviews, put it in ChatGPT and say summarize it. It will give you that, right? Summarize it in 3 sentences. What are the key attributes? Now, people are doing that on the fly. Because the reviews are changing dynamically, you need to generate the content. It's not stored in database every time. Because every minute you are getting a new review. So every minute there's a new summarization which needs to be done. So you need generative content. Or generative content might be images, right? You are generating images based on the user context. Oh, the user is searched for a tent and then he searched for a barbecue. Now, when I'm showing the barbecue image, I'll show it next to a tent, right, in a product image. So then he realizes, oh, for my party, this too looks nice. I want to buy that, right? Earlier, it was all static images. Or the user is like an Asian image, so I'll use an Asian model instead of using a Western model, right? That can be done dynamically right now. It's easy right now. Right now, using a generative content step, you can do that. The other part comes in generative interfaces. This is very powerful. All of you must have heard about plugins, right? ChatGPT has plugins, right? Now, what are plugins is nothing but microservices, right? At the end of the day, plugins are just mini microservices. Your application is no longer hard-coded, right? It's no longer hard-coded to say use service A and service B. Tomorrow, after your application is released, someone can add a service C and your application is expected to use that when it is available, right? The people, when they wrote ChatGPT, they didn't know what plugins are going to be. When people wrote the plugins, it realized that, oh, you want to schedule a calendar. Is there a scheduling plugin? Yes, there is a scheduling plugin. I'll use it to schedule a calendar, right? That is what it is doing, right? So all your applications need to be compatible with this. Like they need to have this plugin architecture. When your application is talking to microservices, it is no longer talking to microservices. It is actually talking to what I call it as agent-first services, right? And earlier you used to write microservice services using bounded context and your interface design. Now the interface design needs to be designed for AI to use, not for developers to use. What does it mean? The nouns, the verbs, and the interface granularity which you create should be compatible with your AI. So that AI can say, okay, I can use these things. The description should be understood by your plugin so that it can use it. So if you design your services, that is how your architecture needs to evolve. The next part is, in terms of input validation, there's generative engineering. Generative engineering is one way of thinking about is generating code. Now, this code generation is not at a development time, at a build time. It also happens at the runtime. So why does runtime code generation matter? Like for example, if someone is uploading an image, you need to validate the image before it comes to the server, right? Now, to validate the image, you might say that, okay, since the person has bought a tent, I want to basically validate that only tent images are uploaded, right? To do that, you can use generative AI steps to create the code, validation code on the fly. The validation code is not hard-coded while you are developing. You write the rules how to generate validation code based on the context, right? So that is the next level of validation you need to think about. Then comes generative agents. Now, store and forward is not again a fixed workflow saying that, okay, when a user updates a system, I'll update 3 systems, or I'll put a flow chart to say update A or update B or update C. With generative agents, what you do is this workflow is dynamic. You will say this is the context and these systems need to be updated. It will figure out what systems need to be updated, or I think in this case I also want to do an alert system. In this case I also want to store this before I update it because this data looks a little different than what I've seen, right? So the systems will generate the flow charts fluidly, right? There will be one base flow and then there will be an add-on flow, right? So how do you do that? I'm almost done, yeah. So when you start introducing these steps, it is not about rewriting everything what you have. It is about taking your existing architecture and figuring out what parts you need to sort of augment to realize the power, right? So you need to start rethinking your cloud native architecture. If people say cloud native architecture, it is already old. It is last decade. We are from 2020 to 2030, we need to be talking about Gen AI architecture, right? Because everything is running on the cloud anyway right now, but very soon what will happen, the models will become smaller and we'll be able to use it everywhere else. So in short, this is the, what you can say, the line of thinking when you want to think about architecture. You need to think about what are the forces which are causing to change, where are the forces causing it to change, and where are the things where I can add value creatively so that I can take the power of my architecture. So moment your application works like this, think about your application will look intelligent. And intelligent applications are what users are expecting right now because they are seeing the power, right? Once they have, like the statement is there, right? Once they have tasted the blood, right? They will expect your search box to work like ChatGPT now. And you have no excuse not to do it because it's just one API call. Right? So you need to sort of evolve your architecture to do that. Now, so all of this coming back to this, be creative about your architecture decisions. Just don't use Gen AI just for speed. If you're just using for speed, you will be left behind because you will be making a faster bicycle where people will be building rockets. Right? So you need to think about what you need to do. So all of this is great. But at Publicis Sapient, what we realized is this has to be a part of your culture, right? So you need to think about creating 10x value, and you can create 10x value with these 6 behaviors which we sort of put, saying that you need to think like a polyglot. That means no longer restrict yourself saying that I'm a front-end engineer, I'm a DevOps or something. Think like a polyglot because now you can be a polyglot. Nothing stops you from doing that. Think about reuse. How are you going to reuse and how are you going to reduce the things which are not required so that the AI does most of it. Be multidimensional. What I mean by multidimensional is think about in terms of experience and product, not just development, right? So I'll stop there. I know I'm running out of time, but if there's any questions, I'll be glad to take or find me somewhere in the hall which are sitting. I can take few questions. Okay, anyone has any questions? Okay, did you like the talk? Thank you. I normally do this, so just bear with me. I just take a selfie with the audience so that I remember. Or can you? examples which we sort of, I actually presented this in React India conference, and I'm just giving you this example. But these just for the generative content. Like that, if you take each pieces, we have created a catalog of 150 use cases you can do right now. Right? So, and only thing which is stopping is actually this, putting creativity in putting the projects. Okay. Thank you, everyone. Thanks for.
Thank you so much, Rakesh, for sharing your insights. It was really insightful. Yes? Yes or no? You-
The same slides are there in, I sort of talked in React India, the same architecture thing. I can send you the YouTube, you can search in YouTube link. Just search for my name and you will get and React India. So the talk is there. Most of the architecture slides are similar, so you can see them.
So a quick quiz, not a quiz, based on his talk, I would say. Rakesh, you have any specific question so that I have some goodies? If someone answers, your question, they get it.
Okay, a very simple question. If you're paying attention, you'll answer it immediately, right? What does the input change into? Okay, what does output change into? Okay, my job is done. They got the gist of the.
Okay, I'm not sure. How can I get this goodie then? Probably somewhat tough questions.
Okay, what are the 4 drivers of architectural change? Now that's a tough one. Oh. Yeah. I was only saying only one thing, generative content. What else? Oh. Agents. You can give it to him. He got most of them. That's cheating. Okay, thank you, everyone. Yeah. No, his question was like, now you said creativity is important. That is the same question they asked me in React India, right? So, is creativity important? I feel that is what differentiates us from machines. We are all more creative than we think. Our definition of creativity is wrong, and we'll all be forced to be creative because we don't have it. It will be learned.
Thanks everyone for joining the session 1. So now you all can go for refreshments. It's there on the 6th floor. And you all can be back by 10 minutes. Okay? Please, make use of the restrooms there. And I just want to reiterate, please tag AZConf whenever, you post in social media. See you all at the next session. Thank you. So hello everybody. I think you all had refreshments, right? Yes? Yeah. Okay. So we'll get started with the next talk. So next up we have Pranjal Singh here. He is working as a lead data scientist at Udaan. How many of you are into online shopping? Like freaks, I would say. Yes. Yeah, so I think I'm really excited for this talk especially. He's going to tell us how all the recommendation system works and how advanced search experience, helps in product discovery, connecting with urban to rural customers. So his talk title is going to be Empowering Bharat's E-commerce Landscape with AI. Over to you.
No, this is fine. Good afternoon, everyone. I said good afternoon. Hi, so I am Pranjal. So brief introduction about me. Currently, I work with Udaan. It's a business-to-business e-commerce company. And as I was flying from Bangalore last evening, so I was thinking that, okay, how is it going to be on the other side of the audience, right? So it's amazing to be back at a campus and then speaking here, right? And then the topic which I am going to speak is something which is close to my heart as well, because I believe how e-commerce has affected us as a consumer in the last 10 years or so. It is actually going to affect small kirana stores, like shops in our neighborhoods, right? So that's the e-commerce part of it. But like we are hearing a lot about Gen AI, LLM in the last 6 months or so. So AI, machine learning is here for quite some time now. And e-commerce is ultimately a product offering. But you know what? At the back end, there is LLMs, there are ML models, there are DS logics, right? Which empowers these e-commerce platforms, and Udaan is one of them. And it actually enables all these stores, shops to run their business, right? And that's what we are going to talk about it. So just bear with me for the next 45 minutes. I'll try to keep this presentation as more application-oriented as possible, so that you are able to relate, right? How as we as a consumer purchase and how our neighborhood guys purchase. So before starting, let me just give you a brief overview why we call this as a Bharat, like e-commerce for Bharat, right? So there have been multiple reports in the last 2 to 3 years, right? Which are saying that, okay, with the onset of 4G and 5G, we are seeing a jump in the demand of consumers using internet. But then there are next billion users, right? Google talks about it quite often. And so is the Indian government. That these are the 50 crore, 60 crore users, right? Who have been left behind. But now they are coming together, right? Because of the power of internet, 5Gs, right? We have heard in the previous talk that how a fast internet can actually affect the life of a person. And that's what Udaan is trying to do with the e-commerce for Bharat. And AI is one of those drivers which is basically affecting their purchasing patterns, which is affecting their business, right? Which is empowering them. There are a lot of stories out there, right? How like e-commerce boom has impacted the life of these kirana stores, how they are making more money, right? How they are able to sell more and more products. So just raise your hands who all know about what Udaan, like who have heard about Udaan before this talk probably. Oh, quite a few. Okay, great. Yeah, so what Udaan is trying to capture is this $50 billion market, right? And it cannot do it on its own, right? A traditional supply chain, a traditional product offering cannot do on its own. There has to be an AI or an ML backing to it, which is basically going to increase the efficiency, increase the output, right? Increase for the betterment of the life of our kirana stores. So yeah, Udaan is like a short intro. Udaan is like a largest B2B e-commerce company, and it basically runs into small, medium, and big enterprises, right? And in total, there are like more than 3 million users who are onboarded onto Udaan. They are like transacting with us, doing more than 5 million transactions per month. And we are present across more than 1,200 cities. And when I say 1,200 cities, you can imagine it is not like Chennai, Bangalore, or Delhi. There are other tier 2, tier 3 cities, which we are calling as Bharat. And this is basically the most exciting place for me personally to be in, because the work which we do is actually going to impact the life of these people, right? And before we go ahead, just one interesting thing which I want to share about is, so even as a data scientist, right, we go on to a lot of market visits. We visit these stores. We understand what they are trying to do. So I visited just one small neighborhood store in Bangalore, in an area called as Begur. So this was like a 60+ aged man, an uncle. He was selling rice from his store. So I just went and asked, okay, what do you do on Udaan? So he told, okay, I do like 4 to 5 lakh of business per month with Udaan. I purchase rice, I purchase dal. And then I asked, like, what do you sell? Like, where do you sell? He said, sir, for me, I am purchasing this in bulk, right? And for the people who are in my neighborhood, they are not very, very tech-verse, right? They don't know how to order from, let's say, Amazon's or somewhere else. And plus, the selections which he offers, right, they have to be competitive with respect to the prices. So he said, okay, this is how my revenue has increased over the period of time. And then he gave me a lot of suggestions also. So it was very, very interesting that, okay, I am going from a tech angle, right? I am a tech person. I am going from that angle, okay. Tell me what are all the product offerings which you are not liking, right? So he gave me both advantages and disadvantages of using an Udaan app. So that's what Udaan is, right? Now this is one example where probably the person knows how to use phone. There are like hundreds of other cases where the person is not even, he or she doesn't have a smartphone. It's more like a basic phone. So then we have a lot of people, what we call as fleet on street. These guys go to these shops. They tell us, okay, they tell these buyers what they should order, what they should search. And do you know what? It is not that this person is telling on its own, okay, hey, this variety of rice you should buy today. It is basically the back-end models, the recommendation models, right, which are empowering this decision making. I'll deep dive into a few of these models in due course. But yeah, that's how it is happening. So at the back end of it, it's the tech, it's the AI, which is empowering the decision making. So as I said, like the previous discussion, like the input, processing, and output for an e-commerce, it is sellers. Then there are a lot of product offerings and in between, and then there are buyers, right? So I'll just walk through few of the decision-making points, right, which are powered by ML. For example, discovery. So discovery is everything such as recommendations, what a buyer is going to see on the app. When the person adds something on the cart, what that person is going to see. Right? Search, the problem statements which we solve are search, ranking, and relevance. Trust and safety. This again is very, very close to my heart. Because, see, when you give offers, when you give discounted rates, and when there are multiple parties involved in a transaction, there are issues of abuse, right? There are issues where the trust gets breached. There are issues when the safety gets breached, right? So there are a lot of other models which power this prevention of fraud and abuse at Udaan. Then planning. This is important because currently we just moved away from the festive season, right? So this is typically a very, very high demand season in an e-commerce. Now you need to have the right forecasting models in place so that your warehouses and hubs are fully stocked up, right? When there are lean seasons, you should know, okay, what are the demands which you are getting for the next 1 week or so that you just don't overstock, because that's like a cost. So yeah, there are forecasting models running at the back end which are powering the planning. Then supply chain. It is all about optimization when it comes to supply chain. Which vehicle should go where, right? How many deliveries can a last mile person make? I talked about the fleet on street, the person who goes to these shops physically and asks the buyers to place orders, right? What should be their route plan, right? So that they are able to get the best business. We also have a credit offering where it's all about giving microcredits to these buyers so that they can basically run their business, right? We are enabling them via our credit system. And again, there are a lot of credit risk models which run at the back end. Then there is customer experience, right? Chatbots, LLMs, all powering that decision making. Pricing and promotions. In an e-commerce market, you have to be very, very competitive with the pricing, plus you have to take care of your margins as well, right? If you just discount a lot, then you are getting business, but then you are losing money as well. So you have to put right prices. Yeah. So now we talked about, okay, what are the different problem statements which we are trying to solve? What is Udaan doing? Now I'll give a rough overview of what our tech stack looks like. So roughly we touch base on all the jargons which are there in the ML world. So we have classical supervised models right running. And just one point of view here is that, see, every model has its own merits and every problem statement requires different kinds of approaches. One model doesn't fit for all purpose. So that's why there are requirements for different use cases. Classical supervised machine learning, right? We have heard about XGBoost, random forest and all. Unsupervised machine learning, we are working on fraud prevention. So yeah, you don't know what a fraud is. Fraud is something which is very, very rare occurrent, but it is something which is anomalous, which deviates from a normal pattern. So you need some kind of unsupervised model to power that. Then there is semi-supervised machine learning, right? Unsupervised machine learning models have their own disadvantages because they don't know actually what is happening. So it has to have some kind of supervision. So that is where semi-supervised machine learning models come in. Deep ML models, everyone knows, right? Graph ML models, I'll talk about recommendations. That is one of the best use cases where a graph ML model actually helps to give the right recommendations to our buyers. Then Gen AI, right? Chatbots, I talked about. Then there are a lot of internal productivity tools which are powered by LLMs like search, API search, and all these things. Once we have this stack, the next and the very important thing is how do you make decisions? Not just to generalize or put it in an abstract way, there are two ways in which typically we make decision. One is when we do batch predictions. One is when we do real-time predictions. Now, real-time predictions has to be very, very fast, right? When you are recommending something to a buyer, as soon as the person opens the app, the item should be there, what you are trying to recommend. Or when the person is trying to make a search, it should be available within milliseconds, right? And as we have seen, right, I've talked to people across different companies. Data scientists and ML people are very, very comfortable with Python these days. And a lot of the traditional systems or backends are either built in Kotlin or Java. So what we did, just to ease the life of our data scientists, we built a framework called as Data Science Gateway. Now the core responsibility of this Data Science Gateway was to talk to the external services, right? There are a lot of microservices. You have to get the right features. You have to get the features from feature store. You have to get the signals from other microservices, right? So this DS gateway was acting as that bridge. On one side is a data scientist who has built a model in Python, and the core responsibility of this Python module is to just do predictions. That's it. But all the network calls, all the high processing things are being done by Kotlin because that's more efficient when it comes to processing, right? So it made the life of a data scientist as well as an engineer very, very easy. And now everyone can build models and deploy within like minutes, right? And yeah, on the right side, we have all the technologies which are powering all this decision making and things. Most of our things are based on Azure. So yeah, Databricks is one of the things which most of the data scientists use, right? Databricks. When I say Databricks, typically the next is PySpark. Yeah. So I think the others are self-explanatory. So those are the technologies which we use. Yeah. So before I move on, I'll just walk you through a case study, which is based on, which is related to search. One important thing or one important learning in the past few years for me personally has been that as a data scientist, we need to find the right. So see, whenever a life cycle of a data science project big insight, you have to plan, right? You have to chalk out a problem, you have to find the juice, right? How much improvement you can make, then what is the right model choice which you have to do. So the very first thing which we typically do is finding the right input and output metrics, and that has tremendously helped us, right, in prioritization, in identifying, okay, what is the right model approach or what is the right approach which we should take. So yeah, same goes for this particular problem statement. Now, as you can see on the right side, there was a misspelling, right, of Surf Excel, and the model gave you actually the right results, but earlier it was not so, right? And even our competitors were also not able to figure out such kind of even simple spelling mistakes. But then we realized, okay, what is the metric which is actually getting affected when these searches go wrong, right? And then we figured out that null search is one of those very, very crucial metric. Now, in short, null search is something, right, when you type something and then you don't get any results, that's a null search. Even though you have those products in your inventory, probably you are not able to find it because your input and output are not getting connected by the right model. So null search was one of those output metrics which we were able to identify, and then we tried to work upon it. So yeah, obviously the question is, what is that right model to fix this problem? Now, if you think about the scale of this problem, you are actually trying to map an input, which is your search query, to thousands or like lakhs of products on your platform. And if you try to transform this problem into ML problem, it is like, it's a multi-class problem, right? But there are like millions of classes. So yeah, the problem is hard. So I agree that there are different approaches to solve this problem. But then in our literature survey and all, we figured out that probably the model which we are using currently just beats all of them. So yeah, as I told, as a user, right, they do a lot of misspellings, mistypings, and then they end up getting no results. And this was the screenshot from our app before this model went live. So yeah, the question was, how should we solve for our core semantic search, which is actually giving us business, right, without affecting our inference times. Inference time has to be in milliseconds, so it cannot go beyond a second, right? It has to be within like 210 milliseconds. So the solution was, there was this paper published in KDD in 2021 around extreme multi-label classification. And this was a very, very interesting paper. The problem it tries to solve is, given that there are millions of labels, how do you identify which is the right one? So I'll not go in detail because probably this is not the right time to talk in detail about this model, and we also don't have time. But I'll give a very, very brief overview of what it does. So at the bottom of this tree, or at the bottom of this model, are the leaf nodes, which are essentially all the listings or products which we have on our platform, like Surf Excel, Sony TV, any mobile phone, right? All those things. And each of these listings are represented by an embedding. Now, this embedding could be of, like, it is up to us. It could be, you can use any embedding for that. But yeah, these listings are transformed into embeddings. And with the listing, we have the descriptions, right? We have all the relevant text. So yeah, it is easy to convert a lot of listings into an embedding. And seeing the historical data, right? Seeing the add to carts, seeing the clicks, we already have some kind of labels available with us, right? That with this search query, what is the right product which you are trying to find? So in a way, we have the labels available. So what XMC model does is, it builds a hierarchical tree, right? From top down. And each of the level is some kind of decision-making point. That, let's say I typed Henko. Like Henko is like a detergent similar to Surf Excel. So it knows, okay, which path it has to traverse. And then ultimately it leads me to the leaf node, giving me the exact listing ID. And then I can show it on the app, right? So in short, every query is transformed into an embedding. And then every leaf node is also a listing, which is which is represented by an embedding. Right, and based on this vector representation, model is able to use, so at the backend it uses spherical k-means to cluster and make up the tree, and then there are like internal classifiers which optimizes for the right split and the weights for each of these search queries, right? Yeah, so the XMC model is what is powering the search, and in terms of the output, right, so the first one is pretty straightforward, that there is no space, so it's like a single token board smartwatch. It is able to identify, okay, what are all the board smartwatches available on the platform. Now, if you look on the right one, the user searched for Henko, right? Unfortunately, at that point of time, we did not have Henko in our inventory. But Henko is ultimately a detergent, right? So it is able to identify, okay, probably let me show Surf Excel. Rather than showing nothing, let me show Surf Excel. Maybe the user purchases it. And no, you know why it is able to do this? Because there is a semantic embedding which is powering this search at the back end, right? And that's why it is able to do that semantic query and get me the similar results. And at the end, in terms of impact, I was talking about null search, right? So see the impact on the null searches. We reduced it by 85%, right? So in most of the queries which now a user is doing on the app, they are able to get some kind of results, right? Our search to A2C conversion is like when a user searches, how many of those searches are converting into an add to cart. So that's like an important metric to track when you are actually doing showing search rankings, or when you are actually showing recommendations. So that also improved by 15%, plus our inference latency was well within 50 milliseconds. So the model was able to all satisfy all our output metric constraints, and yeah, that's what is running currently. Next topic, very, very similar. Now we talked about search, right? When a user searches and then we show, okay, what the user is expecting. Now recommendation is something, right? When you open an app, be it Amazon, be it Udaan, be it Flipkart, right? Any e-commerce, what do you see? Now recommendation can happen at multiple places. It could be on the home page. It could be when you have added something in the cart, right? Amazon shows frequently bought items together. So all those things. So there could be multiple touch points for a recommendation. But ultimately, the aim here is to make the life of our end consumer easy, make the end consumer more efficient. So between a B2C and B2B, in our market surveys, what we have identified, right? B2C users typically, we know what we are looking for, right? And sometimes we just do a straightforward search and then try to get the result, add to cart and buy. But in B2B, there are variations. Some of our customers, right, they want to know, okay, what is available in the market. So it's more like a exploit and the situation where user basically doesn't know what he or she has come to purchase. But then you need to show the right results to that person. And in some cases, the user knows, maybe it's like stocking up the rice inventory, stocking up the tur dal inventory, right? So they don't need to see anything else because they know, okay, what they are trying to buy. So we have to understand all these users from a modeling point of view as well. And these models have to be personalized enough that they don't show random results to these person, right? So in recommendation, there is something called as explore and exploit. Exploit is something which user is expecting and you show. Explore is something which you want to showcase, right? Probably user is not looking for that item, but then you want to show, right? So that's like a explore exploit method which we use in recommendations. And we have categorized our model base into 3 categories. The first one is a graph-based approach. Now here, one of the state-of-the-art models which we use is PyTorch Big Graph. So this is like a user item graph, and they are connected by the actions which a user are doing, right? So a user can do a click on an item. User can add to cart an item. User can just view the price of an item, right? So all those actions are connected between users, connect user and the items. And this model is capable of including the embeddings for both the users as well as the items, right? So you give the feature representations of the users, you give the feature representation for the items, and then this model basically learns and comes back with the embeddings, right? So this is a very, very powerful model, and we have fine-tuned this model for our own use case. On the base offering, it's more like a homogeneous graph neural network model, and since our use case demanded that we need to have a heterogeneous model, so we just tweaked this model, and it is powerful enough. to basically make the right predictions in both an explore and exploit fashion. Next is a Bayesian approach, where we use something called as modified Poisson-Gamma and Poisson-Gamma models. These are very, very statistical models, but very, very powerful, right? These are used when you want to show users something which the user should buy again, right? Because, as you know, Poisson-Gamma model has a factor like lambda, which learns what are the repeat rates, right? So for all the buy it again recommendations, these models are super powerful. Then we have the traditional user item-based models, right? Collaborative filtering, which we all have learned during our college times, right? So again, those are powerful models serving different use cases. Now, just to give a brief overview, I talked about that recommendations are present in multiple places, right? So there is something called as For You page on Udaan, right? Here we show all the personalized recommendations. That probably this is driven by what a user has purchased in the past. If it's a cold start, what people are buying in your neighborhood, right? So that's all what drives a personalized recommendation. That's one kind of recommendation. The other is cart recommendations. When you add something onto the cart, let's say I go on to app and maybe I order something which is, let's say, a t-shirt, then probably it gives me a recommendation of okay, maybe you are interested to buy a jeans as well. So something like that. So that's a cart recommendation. When you add something to the cart, all the other related products which a user is most likely to buy are shown during that period of time. So that's cart recommendation. Then I have buy it again. So there are a lot of users, as I talked about previously, right? They don't want to do something fancy on the app. They just want to buy which they have bought like probably last week or last month. So buy it again recommendations are very, very useful for that. So 2 slides back, I talked about the MPG and PG models. So there was one use case where we were actually empowering our telecallers, right? So you might get a lot of spam calls from different people, right? Credit cards and all those things. But telecallers, right? They are made to do so because the end goal is to get business, right? Now here the case is different because a lot of buyers are organic, and in some cases we already have a fleet on street going on to visit these buyers. But in some cases where buyer needs additional help, so we had a team of telecallers. Now, what these guys were doing is they were running some kind of rules to see, okay, what user has purchased in the app, and then they were helping the buyers to make a decision. Now, we used that MPG model and we extended that model to fit this use case, right? And what we saw that the recommendations which these telecallers were making earlier, that have become 4x better when we powered it by a model, which is the MPG model. And this model actually significantly helped the buyers. It reduced our manpower cost. It made our business more efficient. We got more GMV. So that's how these models are very, very interconnected. And when it comes to recommendations or telling something, okay, telling a buyer that you need to buy something, they power your decision making. Probably the last topic, so trust and safety. Now this is very, very close. So 3 years back when I started working for Udaan, right, I started leading the charter of fraud and abuse prevention. And trust and safety is very, very important, both from a business point of view and from the point of view of a buyer also. Now imagine that your seller has actually shipped a mobile phone, but when it reaches to the buyer, there is a detergent, right? So these all are real cases. Probably we all have heard this in the news, but it happens, right? Now you might be thinking, okay, where does it go wrong? So seller sent the mobile phone, buyer received the detergent. What happened, right? So there are intermediaries involved. There are warehouses, right? There are hubs. There are people who are going out for delivery. So it could happen in multiple places. There's a possibility, right? So as talked about earlier in the previous talks, again, this system needs to be a zero trust system. And a party at fault approach is very, very important. That it could go wrong at any place. Maybe the seller sent the detergent. Maybe the warehouse person changed it in between. And it impacts both business, it impacts our buyer relationship, right? And the buyers might churn off from the platform. and it is very rampant across e-commerce, across whether you go to hyperlocal, whether you go to traditional B2C e-commerce or anywhere, right? So this is what an ecosystem looks like in an e-commerce world. You have buyers, you have sellers, you have warehouses. Warehouses are our large stockyards where most of our inventory lives. Then there are hubs, right? So these are probably very, very near to our pin codes, right? You might have seen when you probably open a tracking page on an Amazon or Flipkart that it has reached to your nearest hub, or it has reached this particular warehouse. So that's what a hub is, right? Then there is the last mile, the person who is picking the item from the hub and then going out for the delivery. So in a B2C world, FOSs are typically not there. But in our case, because a lot of our buyers are not very, very tech savvy, so they need some kind of assistance. So fleet on street, they also go out to help the buyers to place an orders, to investigate the delivery and so on. So this is what a traditional e-commerce ecosystem looks like. And as I said, right, a no trust party at fault approach is very, very crucial. So at different points or at different touch points, you need to have the right models in place, which can prevent fraud, which can prevent abuse, right? Which enables that your system is running with full integrity. So yeah, at Udaan, there are largely three intervention points. I'll not talk about the other ones because probably we don't have much time, as well as they are little more time consuming. So largely three. Onboarding. So in a B2B, right, the things are different for onboarding. In Amazon, we just go, we sign up, right? We put our mobile number, verify an OTP, and that's it. But for a B2B to operate in India, you need to have a valid trade certificate. You need to have a valid license, right, to operate. So a user needs to upload those documents, and then it gets verified, and then you operate. Right? So there are different kinds of risks present, right? We have seen buyers uploading duplicate documents, uploading fake documents. Then there is credit risk, right? When you onboard a buyer onto credit, because of the duplicate documents, when you were giving that buyer a 1 lakh credit limit, now he has opened another account and you give suddenly a 2 lakh credit limit. So that's a business risk. You have geolocation risk. We know that there are areas which are more prone to fraud. There are pin codes which are very, very fraudulent pin codes, right? So your model should be able to comprehend that. Then there are blacklist stores, right? All the IPs, fingerprints, which have been used by the fraudster in the past. Your system should know those. Then the next is, now the buyer has come onto the platform. What next? The buyer will probably place an order. And imagine if this guy was actually fraudulent, what he will do is he will place an order, get the item, replace it with something damaged or faulty, and then return it back, claiming a dispute, right? We lost money over there if it gets approved. But yes, we have powerful models sitting over there which are able to make these decisions within milliseconds, right? They compute 200, 300 of parameters, right, to predict whether this transaction is actually going to be a fraudulent or a genuine transaction, right? So there are order risk model. As soon as an order is placed, whether this order is a fraud order or not. Then there is return, evaluating every return. You upload images, you give a description, okay, what happened, right? You have history of your sellers, okay, what kind of profile the seller which has shipped this product has, right? What is the profile history of this buyer? What kind of location this buyer is coming from? So there are like tons of factors out there which your model can actually understand and make a quick decision. All right. Then RTO. RTO is return to origin. When you actually don't accept a product in an e-commerce world, it just goes back to the origin, right? There are few attempts made. Even if you don't accept the product in that time, it just goes back to the seller. Now, there are frauds done in that. Like a delivery boy can come and say, okay, hey, sir, I delivered the product, but actually he did not even come to your house to deliver, right? So that's like a fake attempt. And it happens quite often, right? It happens even in big cities. Then there is dynamic cash on delivery. So India is a very, very COD driven market, right? We don't want to take a prepayment risk, right? We want to pay cash when we deliver when the product gets delivered. But then buyers actually abuse this, right? Probably sometimes they might not pay the cash. Sometimes they just return back the product. So this all impacts the business. So you'll have, we have a model which basically predicts, okay, how much cash on delivery limit we are going to give this buyer. Let's say this buyer is only eligible for 15% cash on delivery or for 50% cash on delivery. Right. So yeah, these are all the different kinds of models which power the trust and safety at Udan. Now talking about the other ML areas of focus, we have planning, right? I talked about getting the right inventory. Getting the right inventory at right place at right point of time. Inventory is a big cost for any e-commerce, right? Now when I say cost, it is both ways. The cost, the opportunity cost, that is when you don't have the right inventory at place, maybe buyer sees a stock out, right? Then you are losing out on the business. And when you over fulfill your warehouses, right? It's just storage cost, because some of these products like fast moving FMCG products, they have an expiry date, so you cannot over procure. So you always have to maintain both right balance between your opportunity cost and your real estate cost. So yeah, again, the forecasting models, right? Your optimization models are playing a very, very crucial role when we make these planning decisions. Supply chain. Which last mile person should go where, right? How many kilometers or how many tons of loads can a last mile person make in a day? All these optimizations, right? So they are so it's more like a multi-objective optimization. We have to keep in mind of the incentives of the person. We have to keep in mind how much the fuel that person is going to burn when, or that vehicle is going to burn when he or she is going out for delivery, right? So it's again an optimization problem. Credit is a big risk, right? We are giving money in advance to a buyer, so we should be very, very careful that what are the risks associated with this buyer? Are we giving the right credit limit to this buyer? So that's another decision making point for a ML model. Yeah, so that's all. I hope I did not bore you a lot. Any questions? I think. Sorry? Yeah. Okay, thank you. Your question is not very, very clear to me. It's like, yeah. Okay. No, so Udan for us is like fly. Yeah. So currently we have like both Android and iOS, and plus it is available on web app as well. So you can just open or sign up on Chrome or a Firefox browser as well. So yeah, it is available on all the three platforms: web, iOS, and Android. No, this is for all the products. So you basically sign up on an app. If you have a GST or if you have a trade certificate, you sign up, and then every customer has its own portfolio, right? Some sell FMCG, some sell lifestyle, some sell electronics. So depending on the business which you are catering to, you can just.
All in one store. That's what you are putting on.
Sorry?
All in one.
All in one. Yes, that's correct.
Okay. Very good. Very good.
Yeah. Yes. Yeah, so I'll repeat the question. So the question is, there are so many models out there, right? Let's say pick up the recommendation problem. There's Bayesian models, there are graph models, and then there are various trade-offs between the performance, between the latency and all. So how do we pick and choose the right model? So I think the answer to that is, it's a mix of both. It's trial and error, right? When I say trial and error, it's reading about, so the good thing with us applied scientists is that a lot of papers are already there, right? When researchers do, they try out a lot of different things. So with the trial and error method, when you go out to these, look out for these publications, you actually understand, okay, what are the differences between these models and their performances. So that gives you a good head start. And then the second is, typically we follow a similar evolution for a model. Let's say for a particular problem statement, we have seen that the graph model is actually doing very, very good. Then the next iteration is going to be either improvement of that graph model or maybe something which is very, very similar, right? And as I said, in recommendations also, there are different kinds of recommendations. So by it again, probably a graph model cannot solve it very, very nicely, right? By it again, a Bayesian approach is much better. So every problem has its own partner model, right? And it evolves in that direction. So in my personal opinion, I think the first approach, which is just doing the literature survey, and probably I spend weeks of effort doing literature survey just to understand, okay, what is probably the right model for this problem. I think in terms of evolution, the models are actually converging in that direction, right? If you see, so GenAI is there for quite some time. It's that the LLMs and the excess of these LLMs which have made them very, very popular, right? And what these models are now evolving is being multimodal, right? The same model can handle both images, text, audio, and everything. And that's where even all these conventional problem statements or conventional models will converge into. So that's what I believe, and that's how we are seeing the evolution in the last 2 years or so. Yeah, sure.
Yeah,
Just
hi,
one last question.
Yeah, Pranjal, this is Sudhir here. First of all, it was a very insightful session. Thank you for the session. Again, I have my question on the recommendation systems and how do you model around it. See, typically this question is about the null search, what you said, right? See, if the user has not given anything, how do you avoid the bias? Like you're suggesting something which the user has not asked in first place, or maybe he's not even interested in. How do you give a better result and avoid this bias while giving that result? That is the first question I have. And also, could you elaborate on this explore and exploit model when there is nothing given from user end? So these are a couple of questions.
So I think your second, the answer to your second question should answer the first one as well. So explore and exploit, it's like an old method, right? Explore is when probably it's like a cold start. When you don't know the user history, what are you going to recommend, right? And there are a lot of other factors which can actually power your decisions. Something like a fallback. What is popular in that region? What is popular in that pin code? What is popular with those class of buyers, right? Even if the buyer hasn't done any order, what similar items can we show? So that's more like an explore. Now exploit is if a user has already bought something on the platform, show something very, very similar. So you just keep on exploiting on that thing. And that's what, so maintaining the balance between explore and exploit, right, helps you solve that problem of null. So null search, I'll separate it out. Null search is very, very relevant to search. But in recommendations in general, right, when you don't have anything, when you have your own biases, right, when your model has your own biases, then getting the right trade-off between the explore and exploit gives you the right results. And that's what we have seen, right? We have seen it across regions, like the northern parts of India and the eastern parts of India. They have different affinities to explore and exploit. So ultimately, what it boils down to is personalization, right? What you are going to show as a personalized result to this particular buyer. I'm sitting over there, right? We can always talk if you have any other questions. I think because of time, I won't be able to take any questions here. But yeah, we can connect later. Thank you.
Thank you so much, Pranjal. I think, it was a complete 360-degree overview of our shopping experience, right? Yes? Did you all like it? Shout out for him, please. Okay. So just like the previous talk, so we'll have a speaker. He'll ask some, not tough question, I would say, kind of a tricky question. Who answers it or, whose answer he likes the most, he gets to get the goodies.
So the question is, in an e-commerce world, what is that person called who picks up the item from the hub and delivers it to the buyer? I think it came from there. Yes, that's correct. Yeah, sure. This is more like a subjective one. What's a null search? I think everyone knows about this. Do the sponsors have multiple goodies?
If we are not finding it anything, what's the user is trying to find?
That's correct.
Thank you so much.
So thank you everyone for, staying patient up until now. So we'll have our lunch now. So the timing for lunch would be 1 o'clock to 2 o'clock. Just to ensure, please, if you haven't got your lunch coupons, please get it over in the registration desk. And lunch will be provided at the 6th floor. I hope we have an exciting event post lunch. So we all meet at 2 p.m. Thank you so much.
So let's try to open one of the models and go through it. So say we have a Mistral, so, and you see text generation. If you want to generate a text based on the context you are providing, you can use a Mistral model. You can, if you want to have a chatbot application, you can go to Mistral 7B instruction. So you see, these are the metadata associated with the models. This Falcon is for text generation. Similarly, you can scroll down and you can go through any of the models. The thing is very simple. Click on one of the models and you see, you will directly be given an option to fine-tune or deploy a model as well. So pretty simple. This is your entry stage to the Gen AI world. If at all we are not aware of what Gen AI capabilities we have or what exactly is there in the market, go to this platform, try playing with it. And you see, you have the whole information about most of the algorithms that are hosted over here, right? Pretty simple, just the Microsoft way, which most of us love. So you can fine tune, you can deploy. We'll not go into those details, evaluate and all. Then this another important update over here, which is the prompt flow. Yeah. So prompt engineering, most of us are, as of now, aware of most of the Gen AI applications. We provide them an input. In turn, we expect an output. It could be, say, a text summarization. It could be a generation of a text, mod, images, audio, video, whatnot. So with this prompt flow, what you can do is you can create the whole Gen AI application as a drag drop visual on a drag drop and a visual interface. How we used to have our Azure Machine Learning Classic Studio, wherein you can drag a data source, do the data cleaning, apply your model creation over there, and then deploy it. So this is where you can do it. And once you see over here, once you click on create, Microsoft has also provided you few of the quick startup guides. So see, you can do a Q&A on your data, web classifications, and a lot of things. So just give I would suggest everybody to just give a read through it. That will help you get onboarded to the Gen AI world. Okay, so this was not at all related to the topic, but I wanted people to be familiar with this. So with this, let's begin today's topic, which is on basically the architectural pattern for Gen AI applications. So I'm Anurag. I work as a director of IT for Gen AI with Honeywell Technologies. So we are in a very, it's an old organization, but that is where we want to ingrain the new technologies and the Gen AI applications within the old ways of working. So that is where I come into place in the organization. Yes, and my talk would not be catering specifically to Azure, even though I come from the Microsoft and Azure background. I do have little experience on the AWS side as well. So I have kept the presentation very generic, which can be applied on, say, any of the cloud environment, be it on Azure, on AWS, on Google Cloud, and on the open source, in the open source world as well. So it will be a mix of all the cloud environment, a very generic and an open talk, which you can try to incorporate in your use cases. So you guys might be embarking on this journey, and I would love that all of us embark on this journey together. So these are few of the patterns which you can use. Okay, so basically Gen AI, as we say, the generative AI part of the AI world. So AI has been with us for quite some times, but yes, the generative AI is something which was a breakthrough in the year 2017 after the encoder-decoder models came up. And so basically everybody now knows Gen AI because of one breakthrough innovation that happened, and that was the Chat GPT, which was released by OpenAI in November 2022. So with the advent of Chat GPT, what happened? Gen AI was exposed to everybody's normal day-to-day usage. And see, this is, as we say, the iPhone moment when people actually started getting the value of AI into their day-to-day applications. Until November 2022, it was there, but it was in the hands of very few people. And that is where you see, as engineers or as software professionals, our aim should be that how effectively we are able to put an idea into a real world, right? Because until we put any idea into the real world, it makes no sense. Things would be in your book, but until you pass the examination, it does not get a value, right? So it's a similar thing for any of the software products, whether we are developing it, any of the languages, correct? So now people take Gen AI as something called, they have a conception that Chat GPT or any of the GPT models and Gen AI are the same. But Gen AI, as I said, it's basically generative AI. So any AI which has the capability to generate things. Now, this generation can be on the textual front, this generation can be on the visual front, this generation can be on the audio front. So you see, the machine is almost converging the sensory organs of the humans, right? We have the 5 sensory organs. So the machine as well has got the capabilities in terms of visions, speech, and recognition, right? Sense and all are being developed, but yeah, those are something which are in the background. But these few capabilities which is beyond the Chat GPT world. It's not only related to text. We have a lot of use cases in vision, in audio, basically on the factory floors and all. You can merge Industry 4.0 revolution, which IoTs and digital twins, with the Gen AI application. So on a broader level, yeah. So Gen AI on a broader level would be a mix of text generation, image generation, question answering, summarization, and chatbot. These are the broader 5 use cases which people want to operationalize within the industry. And that is where we'll be talking about how we can do that. So prior to going into the details, we have, so for all the, say, the complete plethora of Gen AI, you need to orchestrate, right? So we come from the old world wherein we used to develop, say, the data pipelines wherein we have orchestrators, Airflow, NiFi, ADF, whatever. So similarly, on the OpenAI front or on the open source front, we have something called the LangChain, which was developed in sync with, say, the OpenAI, so that we can orchestrate the whole plethora of the Gen AI use cases or the Gen AI applications which we want. We have offerings in Azure that's called the semantic kernel. We have another open source orchestrator called Llama Index. So you can do a mix and match and do a choice between what do you want to. But yes, semantic kernel is something which is still in an evolving phase. It is not, I would say that it is not very up to the mark as to with the LangChain, but yes, we are there. We will be there. So you can make a choice. And whatever I would be talking after this, the patterns, you can implement everything with, say, 1 or a 2 line of code within the LangChain environment. And this is a normal Python library, open source, available for usage to everybody. So, and you see, these are few of the capabilities like the prompt templates, chains, agents, tool. I'll talk about what are, say, agents, what are chains, prompt templates. But yes, before that, it's just an overview. So, LangChain, or you have, say, as I said, semantic kernel from Microsoft. You have Llama Index as well. So, yeah. Now coming to the very first use case, which is of text generation. So what basically is a text generation? So just consider a case of a chat GPT wherein you go to a chat GPT and you are not asked, you kind of try to give it a use case and you would like to see what the Gen AI or the Open AI or any of the open source generative models think about it. So it is not, I would not say it's a kind of conversation because we have a chatbot pattern as well. But yes, in text generation, you start with the random stuff and then you get ideas generated from the text, from the Gen AI application, and then the series of the series of communication starts. So where can you use such kind of things? So basically, say, you can use it to generate any ideas like, okay, I'm thinking of opening a website in, say, a $10 cost, and what do you think would be a good marketplace for me to host, or what are the technologies I should use, right? So this is what you have given the context to the generative AI, and it comes up with a lot of ideas for you, right? And then you can refine and do like that. Refine and take the communication further. So you give an idea or you give an input to the generative AI model, and it gives back an output. Now, so what's the challenge with this? So I would say that most of the generative AI models, they have something called the token limit. So what is basically a token limit? A token is nothing but basically it is a token is basically the maximum, for us, you can consider a maximum number of words which we can enter at a time. Now, before going into that, why do we say that we are limiting the maximum number of input words? Because at the end, you see, all these models are APIs for us, right? This chat application is just a user interface, but at the end, when we write something on a chat GPT window or any of Bard window or whatever, what happens is there is something which goes inside a web, inside an API, does some calculations and gets back the response to us. So it's a normal API request response pattern. Because it's a normal request response pattern, there has to be a kind of, say, a limit or something which most of these generative AI models have a limit, and that's called a token limit for the models. The token limit also acts on the pricing part, because see, the more token you give, it means that you are making the model more useful in the very first go, right? So what happens is, with models, you would have heard of, say, a Llama, 2 billion, 7 billion, 14 billion, 32 billion parameters and models, tokens, right? So what means is that the model is expanding the breadth, right? So it's capable of taking more inputs. But still, consider a use case in your organization wherein, say, that you have a request which might exceed the number of tokens. And for your information, a Unicode English word, say 100 word, can be basically 75 tokens. So, and most of the models have a token limit of, say, 400K token, 396K token, and things like that. Every model has a different token limit. Now, that is where what happens is, if at all you give a very long sentence to any of the generative AI models on the text front, what happens is the model will not be able to answer you back. Why? Because the token limit is something that's divided in between the input we give and the output we receive from the models, right? So the token limit is a set of, or I would say a summation of the input as well as output. So most of the time we tend to forget that, and we think that each and every say question or each and every Word document which we have, we can simply paste it and we can get an output. No, that's not the case. And it's okay, because see, as users, most of us are exposed to a user interface which actually does not provide us an option that, guys, this is a limit to me, right? Only once we give an input to it, sometimes we do not get an answer, or sometimes we have a problem of hallucination and all. We'll not get into those details. That's a different topic. So basically, you see, there are three different kind of things which patterns which we see over here. One is wherein you are working on a, say, in your organization, it's defined that, guys, you have to use Azure OpenAI, or you have to use, say, an Amazon Bedrock or whatever on the AWS front. So now, or on the Google front, the Vertex AI. So now what you can do is, it's just a normal request response pattern. You give your input request to the model endpoint, you get an output. But this is not how, as we say that we should not be, we should think about cloud agnostic, or say not a vendor locking. These are few of the terminologies which people keep on using, right? For the jargons which we use for any of the enterprise applications. So what happens is, this is something which will be locking you to one of the models, that okay, you have a OpenAI model and you give an input very particular to that model, you get an output. But an orchestrator comes in between. So what's the job of the orchestrator? That, guys, do not worry. Irrespective of what models you are using, I will provide you, say, my environment wherein you just need to, your prompting remains the same. When I'm speaking about prompting, it's basically the input remains the same. But what happens is, you can just change the endpoints of the API within me, and the user need not worry whether I am talking to, say, an Amazon Bedrock, I am talking to an Azure OpenAI, I am talking to, say, a Llama Index, or Meta Llama, or whatever. So this is a normal software engineering principle, right? Wherein we try to orchestrate the upstream and the downstream system. We do not want to make it tightly coupled. And that is where you see the LangChain comes into picture. So that will be my orchestrator, which will hide the details of what model I'm actually calling, or what the API, the model API which I'm calling, right? So you see, when you have that, the second pattern implemented, you need not worry about overall overhaul of your system once you change from, or say, now you're using GPT 3.5. Later you want to change to a GPT-4 model, right? So what happens is, just the model endpoint changes onto the LangChain environment, done. Just a few lines of code, right? So there the orchestration model comes into picture. Now, having said that, what happens is, many times we want our models to reply to us in a very contextual way, right? That before starting, I have a context with me. Like one conversation which you can start with your GenAI application is that I'm pretty lost, but I want to start, say, I want to launch a website with so and so money, let me know about it, right? So this is something which is an open-ended question, which you are throwing to a GenAI application, right? So what happens is, many a times you will get an open-ended answer. So an open-ended answer means that it might not have a very good context. You might be thinking about that, okay, I need to open up, or I need to enter a food chain domain, or I want to enter a cab domain. You have that in mind, but GenAI does not understand, right? You just said that, give me business ideas which can be launched in, say, a 30,000 INR or something. But then what happens is, you get a very open-ended answer. You give an open-ended question, you get an open-ended answer. That is where the concept of context comes into picture. And these are the patterns for our prompt engineering, right? That is why we say that GenAI is more of, say, an engineering or a software principle, rather than the core data science So this is not here to take the data scientist job, but yes, you see, most of the people with the software engineering principles can be onboarded to Gen AI because it's basically at the end an API call, 50%, right? So you see, what happens is, then the another pattern is wherein you want to be very specific. And if you want to be very specific, you need, your manager might have told you a lot of time, see, you are going everywhere. I want you to stick to the context. Or you can say to me, guy, boss, you are going everywhere. Please stick to the context, right? So I went everywhere wherein I was showing the Azure ML portal, right? So that is how. But now we have come to the correct question. So sometimes you take a route, you understand that no, this is not the route I need to take, and then you kind of provide a context. So the next pattern would be wherein you provide a question and you provide a context along with it. So when you, for most of you guys, try doing it in, say, your chat GPT. If not, then Microsoft Edge as well, they have the Copilot integrated, wherein on the Bing chat, you have this available freely. So try to talk to the Bing chat, okay? Once without providing a context and one with providing a context. Your context could be, just try to write a prompt that explain me generative AI. You will get an answer. And you have another question wherein you say that explain me Gen AI as a 5-year-old kid or a 10-year-old kid. And then you see the response generated. So this is where you see, you can think of a broader use case in your organization wherein most of the use cases within organization cannot be without context. It has to be context-driven approaches, right? So that is where you have a context plus you have a input request, you feed it to your Gen AI model and you get an output. So this is how basically the text generation works. Something wherein you orchestrate with any of the orchestrators, LangChain, Llama Index, semantic kernel, whatever. A prompt as an input, you get an output. Another option is a prompt as an input and a context, get a very relevant answer, right? Now, so having said that, now let's come to the text summarization, where in the industry we have files. Like you might have a sales files from your organization, right? A sales or a legal document, which you do not want to you do not want to read through those legal entities which are almost 10 to 20 lines of 10 to 20 pages long. So for most of the software licenses as well, what do we do? Tick, tick, tick. I agree, I agree, I agree. But now, if at all you want to see what's the summarization of the legal or the things which you are ticking, copy paste that, copy it, paste it in any of the Gen AI and see what is the summary of it, what it is that you are ticking, right? So as humans, we never bother. I as well do not bother. We are in a hurry to deploy anything. Click, click, next, next, agree, done. But if at all you now want to see what is the summary, what it is written in the legal document, you can use the text summarization approach for the Gen AI. And see, the very inspiration for my talk over here was that once you start using Gen AI use cases within the industry, what happens is lot of leaders or lot of people will come to you wherein they would want to automate any of the mundane tasks that they are doing. So which ideally is not a very ideal case for a Gen AI as well. As we say that if you can count a number of apples with say one person, because we are not a huge warehouse, why do I need a custom vision problem for counting the number of apples around in a room, right? So that as a manager or as a business leader, you need to keep that in mind, right? That what is the value I'm deriving out of it? And that is why these patterns are important, so that if at all somebody comes to you and he might say that, why don't you automate an email generation with a Gen AI case, right? So basically, email generation is not something which we need to put to a Gen AI use cases. We have better use cases which we can do, right? So with this broader level categories, you would be able to create a funnel within your organization that, okay, these are the use cases which actually I need to take, right? So you have now when you have a summarization model, one thing is an agent is going through a lot of legal documents. He is highlighting with a highlighter, going through, trying to find out the things, right? Now, his job has been kind of redundant, or he can be aligned to a better job to do. And that is where your summarization comes into picture. So now when you have a summarization, it's not that you have 20,000 pages and, or say for one legal contract you have say 30 pages long. It's not that the whole 30 pages PDF you feed at once and you will get an output. Why? Because in the previous PPT we talked about the limit, the token limit for the OpenAI or the GenAI models, right? Every model has a token limit. So say a 20 pages or a 30 pages PDF might exceed the token limit. And that is where what happens is you need to, and what's the next obvious thing which you do? The next obvious thing is you break your documents into chunk sizes and then you send it to your model, right? So that is where your chunking will come into picture. So how do we say that you have a 10,000 page document, you break it into say 1,000 pages of document each, and then you process it in a GenAI, you get a summary from the one. That summary can serve as a context for your next input, right? So this is a whole chain that comes. You break your say a text document or whatever into chunks acceptable within the token limit. And the point is, all these things you can do it as a software engineer. You can do it using a Python code, say LangChain, Llama Index, whatever. You can do it. These seems to be very big and very flashy when we say, but trust me, everybody of us can do it, right? Normal principles that we used to run a for loop before. Here it's a different concept, but it is the same thing, right? You need to break your document, send it to an OpenAI, get a summary out of it, and we talked about in the previous slide the question plus the context, and that forms the input for my second chunk, right? I have the context from the first chunk, send it along with another say 900 documents, get an output. So the output would be a summary of my first chunk plus the summary of my second chunk, get that, send it as a input to the summary of the input to the context to the third chunks, right? So the whole of these things can be within your Python environment, within Azure ML, whatever platform you are using. But yes, this is the thing. Now, you must have a very valid question that, Anurag, you are speaking about chunking the documents. But many a times when we break a sentence or something, there is a few context which is before the sentence as well, right? So it cannot be random that I made a random assumption. Every 900 page I'm breaking it and sending it as a chunk. No, that is where an overlap limit as well comes into picture. So when we talk about an overlap limit, basically I need not be very strict in terms of say an exact 900 pages, wherein you might have a carryover in the next page as well, right? We might have faced similar situations. That is where your say the backward propagation, or taking care that we have some overlap when we are breaking down the documents. So all these things are possible, easily done within the orchestrator libraries which we can use it, okay? Mostly Python is a programming language where we import functions and do it. We have functions readily available for all of these, okay? So this is something which we can use, the chunking model for my text summarization, very big. So now, does that make any of your use cases easier for you to implement? Yes. So say if you have a lot of purchase order or invoices which are generated, or say I want to any of the legal documents, finance documents you want to summarize. What you do is, rather than a 20 people team which actually is doing these tasks, use 10 people for better tasks, enable them with any of the GenAI models, let them summarize. And yes, the core concept of adoption in an, I would say, in any organization is, do not let it go, let any of the AI models flow as it is. You need to have a human feedback in loop, initial days, because these models have their own way of dealing with things. So it's not that the whole team should be I would say the whole team and humans cannot be replaced because limitations are present. So always a human should be there for a feedback for your initial use cases. So yeah, now comes we talked about text generation, which is like you ask GenAI anything. We talked about summarization. Then this is what all of us know, and this was a breakthrough moment for us when ChatGPT was announced. Bard was announced. We used to give them a question, we used to get an answer back, right? So this is something which is a normal question answer pattern, and every organization wants to start, and I think it's a pretty simple and a good use case to start on a Gen AI world within your organization. So prior to this, there was something called the Lewis bot framework or the bot framework from Microsoft, which we used to automate, say, our ticketing, the IT ticketing systems and all. But the limitation was basically those were very generic, or they were kind of a rule-based things. They improved on the rule-based thing. So anybody can have an answer that, okay, we already have a Q&A maker, we have a Lewis chatbot on the Azure cognitive part, then what special are you doing with the Gen AI part? So see, the best, we have a lot of custom vision, translation, and lot of cognitive APIs within Azure portal as well. Most of you might be aware who are working with that. But what special things do these things bring into place is that they are more of, say, learning from generalization to standardization. But the other cognitive services are more standardized. So when I say more standardized, it is like you cannot change the way they behave, right? That's why we say it is very standardized. So say you have the vision APIs from Microsoft, you have, say, this one, form recognizer and things like that. So a mix of things. But what special things these Gen AI models bring to the cognitive world or to the API world is that these have risen from the generalization world, and we are trying to make it more standardized. So it is like our small kid who is with us, and the good things we make him or her learn, he'll be brought up in a way, right? And then he has his own way of learning whatever he wants once he grows up. So that is where your AI runs out of your hand. So the AI ethics and the AI principle comes into picture. Microsoft has that as well within the AI framework. But that is where people start talking about, say, your AI principles and AI ethics and things like that. Okay, so on the question answer front, very similar. You see, you have a user question, the user gives a question, he gets back an answer, right? Now, what happens is, this is where you get, where are these AI models trained? They are basically trained on the internet data. So very generic, Wikipedia or publicly available documents and things like that. So these question answers will not be very specific to your organization. So say that I have a use case wherein I am onboarding a new employee, okay? And I want him to have a very seamless experience, onboarding experience. So one way is wherein he runs from pillar to post and he tries to find out what is my, say, what is the band under which I am, or say how much of, say, what is my medical insurance details, how much of leave balances I have. Many times we do not bother to go to a central portal. We do not remember as well many times. So that is those are the timings wherein such kind of chatbots, imagine that if it is incorporated within your team's environment, you just need to go there, ask, my employee ID is so-and-so, what is the insurance limit for me? Or say my father is getting admitted to the hospital, I have already used my insurance 2 months back, what is the balance I have, right? Rather than giving a phone call to any of the third-party vendors, trying to mix match things and get it. That is where such kind of use cases can come into picture, right? Wherein your answers are more contextually driven from your data. And that is where a very or I would say everybody has been following this one, retrieval augmented generation. So the rag to the riches story we say. So we start and then we get rich on the document constant. So what basically is a retrieval augmented generation? So basically, anything in the any image, any audio, any document, any text in the world of computers is represented as numbers, right? At the end, computers understand zeros and ones and numbers. So that is where your embeddings come into picture. So say you have a image or a video which you pass to your computer. The computer, how does it understand it? Basically, the pixels are broken down into embeddings, or say your photos or your videos or your text ideally are broken into a matrix or a embedding which we call, right? And that embedding provides a value to that particular text. So say that I have a sentence like so my apple, I have got a faulty apple. So you can think of it as a apple as a fruit, or you can think of apple as a Apple device, right? So this is where this context comes into picture and embeddings. So at the end, all your questions or all your text interpretations are represented as numerical values. So if at all you think of a use case wherein say you have a lot of documents in your organization, you take a dump of all the documents which are available, finance, your insurance documents, your legal, everything. Do a one-time embedding of the documents. Like, okay, my organization, all the documents are embedded as a data store. Okay, every document is now a numerical representation. Now, somebody comes up with a question. So, say my employee ID is 5, employee ID 500, band 4. What is the insurance limit? So you see what happens. This question gets converted into your numerical representations, and you already have a numerical representation of all the documents in a database, right? So if you apply a nearest neighbor algorithm, or you try to find the nearest I would say a nearest context to your question, wouldn't you able to get say a very contextually driven answer from the chatbot, right? Because okay, the chatbot got a context that he is employee number 500, he is band 2, he has already used 2 lakh rupees from his insurance. For this year, he has another 5 lakhs or 6 lakhs left. So you see, your question as well gets generated into embeddings. Now, this is where the magic of something called the vector databases come into picture. So you might be hearing a lot about vector databases. So these are, I would say, a set of databases which are very efficient in storing these embeddings, which are basically matrices or numerical representation of text, audios, videos. But you need something. So these are not, I would say, pure SQL, right? Because in pure SQL or no SQL, what do you have? You have, say, a columnar storage or say a relational database. You run your normal SQL, you get an answer. You have all those indexings, everything present, right? So, but for such kind of embeddings wherein you see you have millions and millions of documents, and every row is not a normal, say, row and a column. It is a matrix within a particular row. So you see the search pattern will become so difficult over here, right? That is where, say, the vector databases came into picture. So say within Azure we have something called the cognitive search. Within AWS as well we have I think that's an open search. Yeah, in AWS we have open search. So these, and we have a lot of open source, I would say a lot of open source vector databases. And whether RAG was a good pattern for us or not, but it was definitely a RAG to riches story for all the vector databases, because the moment OpenAI or GenAI was incorporated into organizations, we definitely need to have say vector databases. These were not normal ordinary databases, a database to store your embeddings and doing a search on that. So, and trust me, that search has to be very fast. Why? Because otherwise, imagine a case wherein you have asked your a chatbot for a question and it takes 5 minutes to give back you a response. It's not an intuitive experience you are having, right? You will try to be like, okay, I'm not interested, I'm closing it. It's better I will find it from somewhere, right? So to give that intuitive experience, you needed to have something powerful. And that is where these kind of vector databases came into picture. But yeah, there's a little sad story to these vector databases. How rapidly these vector databases evolved. I would say last week when OpenAI had the first dev day, they announced something called the retrieval API, which kind of kills the usage of vector databases, but still we can, right? So that's a long way to go, but still when we are onboarding or we are trying to incorporate new use cases, let's try to stick to the retrieval augmented generation. So see, very simple. Retrieve your information, augment it with your context, and then supply the answer back, right? Very simple, break the word, retrieval augmented generation. So you retrieve a generalized answer, give a context wherein you augment, and then you get an answer relevant to it, right? So that's the RAG pattern for the Q&A. Most of the organizations start with a Q&A chatbot, and RAG is the way to go. In Azure, you can use a cognitive search, Cosmos DB, Azure OpenAI to come up with such kind of use cases. A Node.js UI for your this one, exposing it to this one. Now comes the So yes, we have the architecture pattern for the chat box. Okay, so basically for a chatbot, apart from the intuitiveness, what is more important? The more important thing is it should be able to maintain the context and the flow, right? Because imagine that I have given my name as say, hi, a chatbot name Red. Okay, hi Red, I am Anurag, I have employee ID this, can you provide me this? So see, if you think of a pattern wherein you reply, your chatbot replies saying that, okay, hi Anurag, based on say my location, good afternoon, how are you doing today? So see, it feels so good. You feel nice to talk about it, right? So just such kind of intuitiveness and such kind of things, how you can do when you have a chat history as well maintained, right? So if at all I'm not maintaining the chat history, what happens is my chatbot will forget in another 2 lines, it will forget that I was talking to Anurag. There's something called a recency bias. What happens is the chatbot keeps on forgetting. So see, this is not a normal human being. The more you train, the better it becomes, right? So that is where what happens is the chatbots have the capability to just keep a track of last 2 contexts or last 3 contexts. But if you're constantly chatting over a period of time, say for say 30 minutes or so, due to whatever reasons, the contexts have to be maintained. So those contexts have to be maintained in outside world, because our chatbots or any of the AI models are not capable of doing that. They just have a limit of few things, right? That is where you can use any of the highly scalable database, say a DynamoDB or a Azure Cosmos DB, for storing your chat history, so that now imagine a case. You have a question, you retrieve, augment with your context, add a chat history and just give an answer. See, so how all these things emerged from what we spoke about. So using the retrieval augmented generation, you give a contextually specific answer, and you also add a chat history to your chatbot as a context, so that it starts giving answer relevant to somebody, right? So this is how all of these things can be plugged together and think about a use case in the organization. Okay, so with this, I think, and the same things can be applied for your AI models, image models as well. So we have whisper models for say audio to text, image models you have like DALI and things like that. So everything is the same. See, instead of a text, there you have an image. Image also has to be broken into chunks. Image context also has to be provided. So even though it was specifically written as text generation, summarization, Q&A and all, but your images are also equally good in doing that. Okay, so that is, and there are few models like GPT-4 wherein text, image, everything in one go. So that is called a multimodal model, wherein all the modalities of text, audio, video within one model. Otherwise, prior to this, it was either a text model or an image model or an audio model. So, okay, so with this, I would end the session. Do we have time for questions, or if at all, we okay, so if anybody has any questions, I'll be happy to take that. So.
Okay, go ahead.
Okay, if we have more than 2, I can obviously take it outside as well. So please feel free about that. Yeah. So.
Okay, Anurag. Thank you so much. From your presentation, I can clearly feel like how depth you have knowledge and hands-on applications and all these things. I have tried all of them, but I have a lot of questions that I thought I'll ask you. The first thing is, right, when I implemented RAG, I used like Pinecone, then use the similarity search, then I have a limit like k equal to 3 or 5. But when a user asks a question which has the answer beyond like 5 documents or 10 documents, how do you handle it in RAG?
Yeah. So that is where you see you need to limit something on the prompting side itself. Because see, there are 2 things over here. One thing is, if the user's answer is somewhere beyond the 5 documents that have come up, it means that the embeddings have not happened properly, right? Because see, your embedding, where we ourselves say that the k nearest neighbor or the ANN or the KNN, right? So what happens is that it means that somewhere there is a problem with the embedding and the indexing, because my embedding or the indexing of my question was not able to give a proper similarity search on this, right?
Yeah.
Because if that was happening correctly, it would have been more nearer to my context, right? That it means that I have got 5 questions, 5 documents which are not relevant. So it means that there is either we need to change the approach. So when you are using the embeddings, ADA or whatever algorithm.
ADA,
Yeah. So we need to try to change that algorithm, try to sometimes change the embedding and see. Or else, there is, on the prompting side itself, see, you can apply few prompt templates and all that users do not go here and there with their questions, right? Because sometimes it's also that obviously we want to just make the chatbot hallucinate, or we want to that's the thing which I would like to do. That, okay, somebody has built it, let me try to crack it. Where exactly it is failing. So that is where those prompting guardrails can also come into picture, and that's why we have a lot of prompt templates. So start with the prompt template so that your vision is narrowed. You people start, I would say, start getting this one. They start getting confidence that, okay, whatever you have developed is actually something working. Otherwise, most of us will try to break the system. So you need to make some, if at all this is happening, try to templatize your this one questions first, store it so that you can train your model on those extra last things as well you are getting. And then we need to look into the embedding models as well, that somewhere that nearest neighbor is not working as expected. Otherwise, I would be getting more relevant documents. So these 2 things we can look, but obviously, first thing we should look into the embedding patterns or the embedding vector store and the embedding models. And then we need to do. And you know what? There's something called, say, ML flow, evaluate and all, where I know that most of us, we are not reached up to the evaluation stage of Gen AI. But if we try to, because we
don't know how to evaluate.
Exactly. So we are still at a stage wherein a lot of people are not aware. Few people are using it. So the next stage is wherein we try to evaluate it. So TrueLens from TrueEra, evaluate from ML flow. With this, these things will obviously reduce, because now what happens is it's a non-tested thing which has gone into the live world. So we are doing a live testing. So it is, so when you are doing a live testing, block your, or I would say templatize your users' input
Okay.
and try to
Sure.
do that.
Yeah.
Definitely we'll have improvements.
Yeah, thank you, Anurag.
Okay. So, yes, if anybody has any question, please feel free to meet me outside. I do not want to take the next speaker's time. Okay? I'm available here. We can discuss. Thank you. Thank you, everybody, for your time today.
Thank you so much for your presentation. As he mentioned, you can, raise all kind of questions that you have, and he'll be, happy to help. So are you guys kind of bored now? Are you guys kind of bored? Yes? Feeling sleepy? Yes? Yes, no? I might want to check the decibel level, so please give a shout out. So let's see, based on the decibel, we can determine if you are energetic or sleepy. We'll go with the countdown. Okay, 3, 2, 1. Let's go again, okay? 3, 2, 1. I'm expecting some more. Can you just increase your decibel? Ready? 3, 2, 1. Right, all right. So we have a quick, a puzzle. I wouldn't say it's a puzzle, it's a picture quiz. You know like connections, right? You just have to connect the pictures and make a word out of it, okay? So the main rule is, now that everybody, you're all scattered here, so it'll be difficult to give goodie for one particular person. So we'll follow, a theme like, if you know the answer, just stand up, raise both of your hands. Our volunteers will see who did first and they'll get the goodies. Okay? So even if you shout your answer out, it's not considered. Okay? So I think I'll start. If you know the answer, please don't shout. It's going to be very simple. So you can just raise your hands or stand up even and, respond to the question. You have to make word out. You can just stand. Serverless, right? It's serverless. Does someone have doubts in this? Or does it make sense? Yeah, okay. Next. Yeah. This one? Oh, I saw his hands first, so. Yeah, it's load balancer. Agreed? No applause even for the person who gave the right answer. This one is quite easy. The black shirt. Yeah. Yeah, it's deep learning, right? What, you guys had different answers? Same answer, okay. This might be tricky or not, I'm not sure. That person, yeah. You can just feel free to tell whatever answer it is. Right, actually right. Why? It's alphabet. It's alpha and bet. Does it make sense? Okay. We'll go for one final one and probably after the talks we can continue. The answer is right, but you should. Yeah, it's Cosmos DB, right? So next up we have. So we have quite a change of plan in the agenda. So the speaker who is to be giving the last talk will be giving the talk now. Apologies for that inconvenience. And the topic will be pushing the limits of generative AI using Azure OpenAI Studio for retail store planogram design. All right, we have our speaker Prajot here. He's going to talk about how large language models are helping with textual data, but then considering numerical and hierarchical data, what are the odds and how can we make use of Gen AI for that? So I think, we can give it over to Prajod right now.
Hello. Yeah. Okay. Thank you. Hi everyone. So sorry we had to swap one session because the other speaker was not available. It was about LLM ops, right? So instead of that, I'll be conducting this session. So this session is about using. Okay, let me just show that. Right? Basically, generative AI, right? You've heard about some of the talks, right? How do we extend the use cases in generative AI? So that's what I'm going to talk about. So we have 45 minutes, maybe a little more, because I got some extra time. And the first half an hour, I'll be talking about the concepts. There are two areas that we need to cover. One is the concept of the business, right? What is a retail planogram? And the other is how to solve the problem, right? So the business actually explains what is the issue that you're trying to solve in business. And the technology side of the talk will cover how we solve it using generative AI. Okay, I think there was a request to talk about LLMs, right? What is LLM? I think somebody asked about that, right? Yeah. Yeah, it is connected. Yeah. So in generative AI, LLM is the underlying concept. Okay. Maybe I'll just go there and then we'll talk about that because just talking. Yeah. Okay. I don't have slides for that because mine was a different thing. So I'm a software architect. You're talking. I was working till 10 days ago. I've stopped to start my own company, generative AI firm. I'm just doing research for a few quarters before I actually name it and start. So, and I've been working in generative AI and AI for since 2011-12. Generative AI maybe last 1 year. And this is one of the use cases that we have built for a customer. And we have seen this interest for this in multiple places. Okay. So let's see, what is LLM, right? So one gentleman asked, right? So LLM is a large language model. That means so many things. So let me just see if I have some content for that. So my introduction. So I'm just skipping through the stuff so that I can see and I can diagrammatically show you something. Okay. So yeah, I'll go back to the original stuff once we cover this. Okay. So LLM is a large language model, which is big neural network with its weights and biases that it has been trained on, right? So large, what is large here? I mean, model itself is large, but the data that it's been trained on is even larger, right? Terabytes, right? And the model size itself is in gigabytes. So, and why it is different? So earlier we had the neural network, right? I studied computer science, so my textbook was from 80s, the textbook, but I studied later. At that time we studied all theory because we could not run these on GPUs, cheap machines like we have now, and those machines did not even exist. So those, even if you could do it, right, those, whatever model you built was small because they are not large. Because data itself was not available. Why? Because there was no internet. Why we are able to do all this big stuff now is because there is the internet and the cell phone, like in another conference, another person was telling me. The phone has become so cheap and the images have become so cheap. Without those millions of images, the cheap images generated from these phones, we could not have image nets and computer vision like this at this level. So crowdsourced data, right? Text and images and videos and 3D models are coming later because we don't have enough videos compared to images, or words are much more than images that way. So you take this data and train your neural network using terawatts of power and create neural networks that understand this, right? And there is another aspect, how there is a limit beyond which humans cannot train, okay? So some of these large language models have gone through something called self-supervised learning. So if it's supervised, there's a limitation is how many people can sit in a hall and train these models, right? Correct, or create content to train these models. So there's a process of self-supervised learning, reinforcement learning corrected by self-supervised learning. A lot of other concepts that have emerged to make these large language models possible. Okay, so that's the higher level concept. And you would have heard the word GPT, right? So when you say a large language model, GPT is another important thing. So it's generative pre-trained transformer. Okay, so a transformer is the core of the architecture in these large language models. And that, what it does is, ultimately what the transformer does is take some data and transform it into some other format, okay? But, so I'm not going to the details of what the actual transformer does, because that's another session. So, what they've done with, like, for example, like you have an English language LLM, right? So assume, no, you're not looking at, okay, the LLM that knows English and French and Python and C and all things. Just look at English language LLM. What has been done is you trained it on the internet, and it has been pre-trained on English. So now what is this? It's become a huge giant. It is the best English speaker on the planet, pre-trained, right? So now you take that, then you can make it do different things, right? Like for example, that we'll see now, right? So you got this pre-trained expert, biggest expert in the world on English, and it is done in organic learning from all the data on the internet. So, and why it is called G? What the G is generative. That means this guy can generate a lot of text that not only is not there in its training data, right? It's not that you can, okay, I'll just reorganize data that I learned and put it out. No, it can generate stuff which is not even there, right? But it makes sense, right? Grammatically correct English. So if you've been playing around with ChatGPT, you will be surprised or amazed about how good its English is, right? My English is pretty good, I think, okay? So, but I'm really amazed by how it answers, right? Okay, let's, I hope this is okay, the high-level summary of LLM. Okay. So I'll just start my session. Go back to the table of contents. Okay, so I just touched upon planogram. So what we're going to do is, so planogram design. Has anybody heard about planogram, what it is? Okay, one. Anybody else? Two. Yeah, so as expected, because 5 years ago, even I didn't know what is a planogram, because, so we were building this shopping robots, right? So that means we were actually building robot that would, actually you give an order on an app, a robot will go and pick up the items and fill your basket and give it to you. So then some retail domain guy said, we want to do planogram compliance with these robots. So like, what is planogram compliance, right? Planogram compliance is making sure that, so planogram is, okay, let's not jump too much there. Instead of, let's see the table of contents now. So I will see what is generative AI, right? Okay. So this is the table of contents. We'll see what is generative AI, quick intro. Then we'll look at what it can do and what it cannot do. And then we'll store on planogram. That's where I'll explain that in more detail. Then why is this a business challenge, right? Planogram design, why is it a challenge? And how can we use generative AI in planogram design? And we'll also look at how you guys can use this, okay? So maybe you are not interested in planogram design, right? I didn't come here to teach you planogram design, but how is this technique that I'm going to show usable across any other use cases that you guys will see in enterprises, right? Essentially, I have a slide about that. So, like, how do you use generative AI and integrate it with enterprise databases? You've seen talks about PDFs, Word documents, pure text files using RAG search, retrieval augmented generation search. That does not work when your data is in tabular format. Because all the data that LLMs have been trained primarily are on text data, right? Sequential, nice English, not tabular data where columns, columns are related to each other, right? So when a text reader goes through columnar data or hierarchical data, it cannot interpret that as like a sentence. So that's another challenge. So then, towards the end, we'll see some code, right, based on the time we have, okay? And I'll also try to make it a little more complex because planograms have rules. So let's see, not jump ahead there, okay? So what is generative AI? So AI that generates stuff, so it's pretty simple. If you have been learning classical machine learning, this was there in the original classical machine learning methods also, right? where it generates, it can generate text, images or not. But the key thing is, let's see, okay. So a generative AI that generates images, you just give a prompt, okay, like this. You generate image of a playful puppy. It could generate this nice looking picture, okay. But this, it's not actually as easy as it's shown in the slide, because normally to get such a nice picture, you have to write a bigger prompt. You have to do many iterations. For this presentation, I just show this. But this is actually a generated image, by the way, from some website. Okay? And the second point, right, that's very important. Generative AI versus discriminative AI. So you can see the example there, right? So you give this image to a discriminative model, and it says, ask the question, is this a cat or a dog, right? Then it can actually tell. So that kind of models are discriminative models. So that's an example, okay? So has been, so before this generative AI became so popular, like you can see all these classification tasks are discrimination tasks. That means you have to tell is this spam or non-spam, right? You are getting, your spam filters nowadays are based on machine learning. So it says, is it spam or non-spam? Those models are discriminative models. So generative AI based on generative models. Okay. And I think I've spoken about transformers slightly, right? So it can transform one set of data to another. So transformers are basically sequence to sequence. That means you take a set of words or anything else, right? It could be a set of images or a single image, and generate another set of sequences. Basically, so a set of words is a prompt that you say, and so generate image of playful puppy. For an image model would be, it will generate an image, right? But can you write an essay about a playful puppy? It will generate a set of words. If it's ChatGPT, it will generate an essay. So basically a set of words being translated to another set of words. So sequence to sequence. So it transforms a set of something, right? Words to another set of words. And I think I've spoken about large language models, so we'll skip that part. Okay. And yeah, I think it's pretty obvious what it can do now, right? So it can generate all kinds of content based on your prompt, images, text. Some things that are not very obvious is, it can actually generate 3D stuff that you probably have not seen, because there's not enough 3D material freely created in the world using cheap cameras. That's why it's difficult to create 3D models. So maybe 5 years down the line, I came from Bangalore for this presentation, but 5 years down the line, Azure Conf Chennai, I can be here without being here. You will feel that I'm here, I'm talking, but I'll be at home, doing this presentation. That needs a different kind of AI, basically a 3D version of me being projected here. And you would have seen in some YouTube, right? I don't know if you're following this AI. There are some keynotes in the US where this happened, but even there we can tell it's not that high res. So holographic projections. Okay. Yeah, and this is the other sequence to sequence point I've mentioned, right? In ChatGPT, right, any output word that you see is not just based on your prompt. It's also based on what ChatGPT already output earlier. So maybe it's writing the essay for you. So it wrote that 9 words out of the essay. Before writing the 10th word, it also uses the 9 word also as input. So that's another important point to remember, okay? So its output quality depends also on its own output quality, not just on your prompt. And that is important in our solution, because I will be generating this retail parallelogram design based on a sequence of queries. So every time I give its own answers back to it. So it's not that I give a new prompt. I give 3 prompts, but I give the 3rd prompt and also its last answer, that last 2 answers back to ChatGPT. Basically the API call, OpenAI API call. Okay. So that's the concept of the last part, right? Conversation you can have, right? This is an AI that you can have a conversation with. For example, you ask, right? I got this exception. You're all developers, right? So we copy paste this exception into Google and say, oh, it found some answers, or maybe it didn't find. But you can't ask Google, hey, your answer is useless. You can't say that, right? But in ChatGPT, you can say, hey, your answer, I could not make any sense. Your answer was useless. Can you give me another answer? And GPT will give that. That context and conversation is possible. So this is a different kind of AI that we are working with. Okay, so what it cannot do, right? So that's another point I put in brackets as of now, right? Because every day or every week, every month, it's changing. Okay. So it can't connect to external systems, right? For example, the ChatGPT thing, right? So you ask the system at the web browser level, or you give a API request. It's running somewhere on a server on the cloud, but it needs some data from some other API or your enterprise database. Even if you give permission, it can't connect and get the data. So that's one thing it can't do. The other is long conversations. I think the earlier speaker mentioned that, right? You give the longer your conversation goes, it tends to forget that, right? maybe it falls out of memory, right? So you will see that you try to connect your questions later. 10th question to some point in question number 1 or 2, it doesn't answer correctly. But if your 10th question is also referring to something in question number 9 or 8, it actually remembers that. So longer the conversation, it loses the track. Yeah, and the other point is handling tabular data, like I said, right? I'll show you some of the data. So if you, tabular data, it has columns and rows. So it's not the sentence, right? So column 1 is normally semantically closer to column 2 instead of column 1 and 10, right? So that kind of things, these models cannot really understand, right? Column 1 and column 2 are the meaning of column 1, right? Column 2 will be similar. There should be something like that, right? And when you ask questions like that, it's not able to answer. Another is mathematical thing, right? You think, okay, it's a very smart guy. It can do 2,300 plus 33. It can add, right? 2,333. But sometimes it will go wrong. Randomly it will go wrong. So it's not, because it's not been trained on mathematics. The training has happened on text. That is the core reason, okay? But it's changing, okay? Like I said, it's changing. So you can, so it's like sort of like reinventing the wheel, okay? So because thousands of years people are being good at adding 2 plus 3, but you get this highly intelligent guy who comes and he don't know how to add 2 plus 3. It's like that. But that's the thing with computers and AI is that its learning rate is much faster. So human takes 10 years, AI can learn in 10 hours. So that is the thing. And it's that, they have not been trained on mathematics, right? So the newer models, I'm actually seeing that it's happening. But the last point is very interesting. So you think you want to, that's relevant for this also, right? So maybe, we want to arrange people in the hall based on the companies you are from, right? Or the colleges you are from. Then, okay, some company wants it on the top left. Basically, some kind of optimization we want to do. But you ask ChatGPT for that, right? Because I give, okay, company 1 has 20 people, company 3 has 40 people. So basically a best arrangement. If you ask ChatGPT, will not be able to do it. This I found, so I was creating this Coursera course on generative AI, okay? So you want to, next month you will see a Coursera course on generative AI as your coding buddy, which I have created in Fractal. So there the instructional designer asked me, hey, let's start with a simple code, right? Where it will generate a clock. So code a JavaScript clock for me. So I said, okay, it's simple, right? So I asked ChatGPT to code this. So it coded this big, nice 3-page code, JavaScript plus HTML and CSS. Then I saved it in an HTML file and opened it. Then only circle is there. I was like, where is the clock? So then I looked again. So these hands are outside the clock. So the visual thing, right? North, south, east, west thing, it's not really clear because it's not looking at it, right? What it learned is text. Like we are learning with eyes also, right? So that vision part is not there, right, in ChatGPT. So now it's come, right, GPTV, you can actually give a, so I spent a lot of time trying to train it, so, but the code was useful because for me, I was not very good expert in CSS. So it gave me a lot of CSS, how to do it. So I could take that working code and arrange the clock correctly. So it saved me a lot of time. But that visual thing is, and in planogram, how to arrange stuff in the shelf. Basically planogram is about that. That's why. Okay, we've seen this slide earlier in another context, but this is very important for my talk. So, hey, what is my time? Because I was supposed to be on another time zone. There's no timekeeper. Okay. No. Yeah, 3:15 we started, I think, right? Okay, so 15, so 15, okay. So my plan is to complete as per that 1 hour, 45 minutes thing. I'm just keep 25 minutes, right? Yeah. Yeah, 35, yeah. So I want to finish these slides in the next 15 minutes so that I can show you some code also. So this is the core thing, right? Planogram is not the core thing that you guys should take away from this session. How LLM can be made to use the two things, okay? Use enterprise data and then understand enterprise data. Using is not the same as understanding. Using is here, I'm just meaning connecting. How to make your LLM connect. That dotted line is a connection, right? LLM, I said, right, in the earlier slide, LLMs can't connect to external systems. External integration is not possible. So in this presentation, you'll see how to make that change. And then enterprise data is mostly in tabular format, Excel sheets, relational tables. It's not Word documents, or some other PDFs, right? So that numerical data primarily, right? So how to do that? And just keep this in your mind. Okay, let's see. So, okay, this is a nice slide which shows what is a planogram, right? So this actually defines a planogram. So how shelves and displays are arranged inside a store, okay? So you go to a retail store, you'll see, right, entry point, exit point, shelves are arranged, and there are different aisles, right? There are, food items, then breakfast items, right? And then toys, then chocolates, right? Different areas, right? So those are actually designed by experts, okay, to make maximum sale. And this is actually a mathematical optimization problem, okay, in larger stores to make more and more revenue and do better than their competitors. Planograms are designed by experts with the help of tools that actually help them optimize. I don't know if you've done operational research algorithms, if you've learned. Yeah. So those algorithms primarily used to optimize, which to place where, right? And now suppose you look at, chocolates in the front, then, the fresh vegetables on the right? All those things you placed, but then, the shelves, right? Within the shelf, row 1, row 2, row 3 are actually also part of planogram design. That's what the two diagrams are, okay? The first one shows the layout, top view, okay, where the shelves are placed. If it's not visible, it's like electronics on the top. I think food items here. The green one shows the billing counter, music, stuff on the bottom. And within each area, right, in the shelf, you can see, right, where to keep what is also part of planogram design. And I'm only going to show you within a shelf layout problem now. Yeah. 15 minutes, okay. What was it? I didn't see that. 15 minutes or? — 20 minutes, yeah, okay. All right. So, let's look at the bigger thing picture, okay? So I explained what it does. The bigger picture is, so how is this done, okay? So suppose, you are suppose I'm Cadbury's, right? I make Cadbury's, all kinds of Cadbury brands, chocolates. So I want to place in more store in at somewhere, right? Okay, in Bangalore or Chennai, right? I'll go to the store, actually fly into the store, and I will tell, okay, I want my items here, this shelf there. The store manager will say, no, hey, I have Nestle also to place, so I will not give you all the shelf spaces, right? So my intent is to sell more of my products, but the store owner's intent is to make more profit for himself, right? And then Nestle also will come and say, hey, no, you can't give all the spaces to Cadbury's guys, right? I also want my space. So it's opposing views are also there. So it's a little challenging problem. So I'll actually go there, and then I'll have some laborers more on the shelf. Even moving items from top row to bottom row is also difficult. So we actually built a virtual reality solution for this. You wear a headset, you sit in your original, wherever your factory is. You can actually be in the Chennai More store without actually going there. You can save a lot of time. You don't have to fly into the location, right? Because that flying, staying there, it's a huge hassle, right? The decision part of how to arrange the thing, right, is what we worked with the AI, OpenAI ChatGPT solution. Okay? And then how you arrange is it's an optimization problem of, okay, you want more revenue or more profits, right? More revenue could maybe, because some products will give you more revenue, you just sell more of it. But for every 50 rupees, Snickers, you may be making only 5 rupees. So margin is very less. But if you sell 1,000 of them, right, a day, it's very high revenue. So you have to decide, and based on seasons, it's like November or December, different products sell differently. So you would see that, right? You actually go to store, you will see that stuff are arranged in different places. Even the shelf arrangement may be different. Okay, let's look at product dimensions. So these are parameters, right? So I'm going to ask ChatGPT, okay, give me a planogram design. Okay, I'll just write a big request. So these are the parameters I'll give, okay? Okay, not disconnected, huh? Yeah, I'm connected. Yeah, I'm connected, so there's no issue here. There's something there. Back, huh? Oh, there's some, yeah, it's come back. I don't know why. Maybe it's lose contact. Okay, thanks. Okay. So when you give ChatGPT, right, a request to do that, you have to give product dimension, right? Because I'll say, shelf, I can give my shelf dimension. I got to say, okay, one shelf, how many items can be put, right? If it's a human, I can tell, right? He can look at it and tell, but ChatGPT can't tell all that. So these are the things I have to give. I have to give product dimensions, right? 10 centimeter wide chocolate box. My shelf is 3 meters wide or something like that. What is height and all that we have to give. Then product names I have to give, right? So all this combined, right? If you give a big description, it looks pretty complex. And you would normally hard code the product names, right? I will say, okay, suppose you are designing for the chocolate aisle, I'll show you some example here, okay? Okay, this is sample prompt, okay? So I'm going to give ChatGPT this request. You are an expert planogram designer, okay? I need your help in designing retail store shelf in Bangalore, okay? It's important to read the entire thing, but I'll just point out the pain points, okay? I mentioned that it can hold a total of 20 chocolate boxes, and there are 5 columns and 4 rows. And I've highlighted stuff which we should not be written there, okay? You don't want to hard code the names of chocolates in that, because I have definitely more than 4 chocolates, right? I may have 50, right? So you want all this data to come from a database. So we are defining the problem here, okay? So we want this data to come from the database. And the UI part, that we have some UI, right, or the planogram designer uses, right? That's marked in yellow, right? These things should be marked in. So this can go as prompt. The final prompt can have this, but original in your program, it should not be like this. It should be picked up from somewhere, right? So that's what we want to do, okay? So, and why this matrix at the bottom is because I want to programmatically generate, because we want to, in a virtual reality world, you want to show in the real shelf, right? So I say, okay, generate in this format. Your output should come like this so that I can parse it easily. So that's why this matrix thing I've given. Okay. So that's a 5 by 4 shelf. Okay. That matrix. Okay. So I actually when I give this, okay, that original prompt, this is what the ChatGPT gives. Okay. I just given it here so that's easy for you to, and it gives very nice explanation. Okay. So if you think, right, the large language models have a huge achievement, okay, because you don't have to explain what is a planogram. It knows what is planogram. It knows, hey, eye level is good for big sales. First column is good for, because when you enter, you see chocolate in the first column, your eye will catch that. It knows all that. Okay, there are a lot of implicit knowledge that comes. Okay, the other point, okay. I want to mention this, I said the tabular data, right? So if you have the tabular data, it's not easy for ChatGPT kind of things to understand. Yeah. Thanks. And hierarchical and graphical data, okay. So let's look at this tabular data. So you can see that, right? I've just screenshot this from a Excel sheet, okay. So you can see that the second column has the same person's name twice. So, and it's just showing each employee how many hours they have worked, okay. That's column 2 and column, I think, 6 are the most important. And if you give this data, because LLMs have not been trained primarily on tabular data, it doesn't work well. So one way is to make it little hierarchical. That means this is hierarchical, but this is also will not work. But there's a different hierarchy representation. So this is a little more normalized table format. It's the same table. I just normalized it so that you can have employee project ID. And this is how you put it in a relational database. Okay. So when I'm going to create the solution, right, we are step by step creating the solution there. So the solution is, provide the data into context. So you have to provide all that hard-coded data. Somehow you have to provide in the context. Okay. So the intent is that all that highlighted hard-coded data, I should remove it. Somehow you have to give it. Okay. And there's a new feature called function calling. I don't know if any of you have heard about this. This is released in June version. For anybody used function calling? Yeah, I think so. Yes, one person has used. Yeah. So this is one way that OpenAI and Microsoft has enabled enterprise integration. That means LLM can actually ask you, hey, I need this data. So it cannot connect and pick up some data by itself, but it can, instead of responding to your query, it will say, hey, give me this data. Then you can actually provide, go execute the SQL query, get the data and provide it as step number 2. So that's, yeah, I'll just show you towards the end, okay. The other point is, suppose you give the data, it may still not understand it, right? Because it's still in tabular format and all. So the easy way, like I mentioned, right? We actually found that you convert this tabular into little hierarchical, create a hierarchy of data. That means, and which is in a, for example, like XML or JSON format, right? JSON format is more common and more understood by, and the other is, of course, you can create the entire thing in basically retrain your LLM, fine tuning, right? Which is much more costly and harder. Okay, so I'm just showing the same sample prompt again so that it's useful for the next slide. So what we want to do is, all this blue marked text, we want to remove from this prompt, right? And how do you do that? And this is the answer that I got, okay, when I give that original prompt. Now I've crossed out the blue mark text here. So I want to give this prompt, crossed out text will not be there. And you want to get a similar answer. And this is one way, okay, I said the hierarchical data, right? You extract the data from your database and provide it, I've put that JSON in 2 columns, okay? So that it's easier to show here, otherwise the font will be too small, okay? So what I'm giving is, you can see that, right? market share percentage, all this Munch, Milky Bar, Kit Kat, these are different numbers, sales numbers of these products, okay? Instead of hard coding in the prompt, I'll just give the prompt without those hard coding, and I'll give this as a separate JSON, as a separate entry. So that is the solution that we've been tried out, okay? And and then the other thing I did is this yellow part, right? I want to prioritize sales margin, right? I've said, okay, if I give that question, yeah, okay, thanks. This is the output I'm getting. So for most of you who've not read those numbers, Milky Bar has the highest margin, okay? And actually it is given, it says, this is the suggestion from ChatGPT, okay? It says Milky Bar on top, then bar 1 has second sales margin. Basically what it's done is it's ordered, right? Highest sales margin product to first row, second sales margin on second row. I'll show you another answer, and okay. And actually the data I have copied here, right? So 15%, right? So it's first row, 12% second row, Kit Kat third row. So basically it looks easier for us, but it's not easy for LLM to do this, okay? Primarily it's also a mathematical operation. Let's look at market share. I changed priority to margin, from market share to market share, okay? Now it is put Munch on top, okay? Because Munch has 40% market share. Got it, right? But it's not blindly done exactly like that, okay? You can see Munch, there are first row, then second row sum, right? Basically it is split the total 20 cells in the shelf by a percentage, 40%, 30%, 20%. And it doesn't add up to 100, okay? Because in my this is a sample data set. So it has actually done a good job, okay? Now what we want to do is make this a little more complex, because this is not a normal planogram thing, okay? You cannot, monopolize first row for one product. You will never see that in any shop, right? For complete first row for one chocolate. There are planogram rules which says something like this. Okay, code time is now, but I want to show something more which I'm not going to come back to. The planogram rule will say, okay, you can have maximum of 3 Munch in the first row. Okay, Milky Bar also maximum 3. And Kit Kat maximum 2. So these are additional complexity items which I have not given, okay. I will not look at that because our intent is not to solve the problem in this session. I will just look at the code so that you can see some sample of how it's working. I think I have 5 minutes, right? 10. Okay, thanks. Is the font good enough? Can all of you see? I can increase it if it's not. Okay. I think I need to wait. Let me duplicate the text. So you may see some ready-made template. I don't know if you've used function calling. So this is like some GitHub code I've taken and completely rewritten it to solve our problem. Okay. So they have some weather kind of example, and what I've done is so you can see the comments. Maybe initial comments are all from them, but the complete code is completely new. And if anybody is interested, looking at this code, I'll upload this on GitHub maybe next week or sometime. So I was told by Anbu, right, okay, people are interested in looking at code, but that was like 4 days ago. And I thought, okay, I can just code it. But last week there was this new launch of the API and all the code is not working. Even the example code internet is also not working. Whatever they have on their GitHub code is also not working. Only yesterday 2 a.m. I got this working. So there may be some problems and I'm not going to run it. But good thing about Notebook is all the output is captured, okay? And because one reason I didn't want to show code is it's difficult to explain this code in a scenario like this. because there are too complex stuff here, okay? So this is the function that I'm using to call ChatGPT, okay? So this will be called multiple times, okay? And it's passing all the messages, okay? So this message size, it will be an array of messages. Every time I call it, the array size will keep increasing, okay? Tools is what the function is, okay? Basically, I have written my own Python function to fetch some data and give it back to ChatGPT. And this is a little more detail, and I can, of course, change the model, no? So in the newer models launched in November, they are much more better in understanding JSON and tabular data. So that's why I wanted to use the new code also, okay? So this, I'm not going to this function, no. The main point is here. So this is one way to do this, okay? This is, I'm creating a dictionary. Yeah, 5 minutes, yeah. I have 5 minutes, I have like maybe 4 cells left. Yeah, okay, I can do that. And Q&A is after that, right? Yes. Yeah. So you can see this like a funny way, okay? I'm defining a function inside a array, and there's a dict inside that, okay? This is not new for people who have seen Python, but this is not how you define a function in Python, right? You don't write a dictionary and call it a function. So this definition is to tell ChatGPT, hey, I have this function with me. If you want, tell me, I'll call it, execute this function for you. So this is just a definition of a function, It's like a documentation. You're documenting your function. You can see that the name of the function. Description is very important. Only that's how ChatGPT knows, hey, this is what I can do, right? So what you do is you give you a big prompt that I showed earlier, right? Please design the planogram and all that. And also give this function as another argument in the API call. Then it will look at this, okay, get sales information function is there. Okay, then it will tell, instead of giving me the planogram, that big array, it will tell, hey, call this function and give me the data. Then the next call to ChatGPT, I have a function, actual Python definition of this function later. I'll call that and get the data from that function and give us one more call. That output of my function call I will give to ChatGPT with the original prompt, right? Please design a planogram with all these chocolates. Then that's what you can see later, okay? So this is the function and planogram prompt is here, okay? This is that big thing. So that I showed in the PPT, right? And this is my function, okay? It's very small because my data is in the JSON file. I'm just reading it and sending it back. You could read it from a database and send it back also. And I'm saying, okay, this is like a syntax for, see, this is that original function definition, chat completion request thing. And I'm saying, okay, this function is there available. If you want, you call it, right? Sometimes you can say, sometimes maybe ChatGPT knows all this data, right? So then it gives me the response, okay? It says, hey, call this function. So what I'm doing is, this is a wrapper function call to actually call my function. I'm calling this function and returning that as a JSON, and that is called passed here, okay? That results, I'm capturing that results and passing it in the second call, okay? Then I'm getting a complete planogram here. Yeah, the output is not highly visible, so I'll show you it in Notepad. It copied in Notepad. Where's my Notepad? Yeah. Yeah. And I've highlighted it here. Okay. So, yeah, this debug output, but that highlighted blue text is what it's giving. So, it's giving me the output for, I think I've mentioned month is here, that square bracket array, right? So now I got the output from LLM about products with some sales data, but it's not even aware, right? So ChatGPT is not aware of how much Munch or Milky Bar I sold in the market because it's in my enterprise database. But now I made it give me a planogram design using my prompt and this data. It is able to use both. So that's the overall thing I had to show today. Yeah. This part we've already talked about. Yeah. So it's time for any questions. More complex? I mean, there's another question. Okay, yeah. So I just showed the initial steps of integrating and getting the initial versions. So this has to be deployed in production for some time and see, okay, you deploy it in a shop and see, is it actually worth? The one point is the users of these tools, right? It's not me, right? If I use this tool and say, okay, this is nice, put it in the shop, they may lose money, right? The experts in planogram, you have to use these tools and then decide, okay. Because first time I'll say, yeah, I don't like this. No, I don't like it. Then you give certain more constraints, then it can give another design, right? Then finally I like it. Suppose I'm the expert, I like it. Then I say, okay, put that in the shop because it involves a lot of physical effort, right? Moving the shelves around, moving the times around, yeah. And it's done maybe every month, every quarter. So that's a effort, yeah. Question back.
So you're sending the data through function calling, right?
I think the audio is, can you come, put it closer to the mouth, I think.
Is it fine now?
Yeah, just say.
Yeah, you are sending the data to GPT through function calling, right? Is there any limitation on the amount of data we send through the function calling?
Yeah, it's the context size, right? It's the context size. So it's not separate from your original context size. So if you have 16K tokens, 16K tokens is limit. Now you support even 128K tokens. So that is a limit.
So the token restrictions remains the same.
Yeah. And its charging is also based on tokens.
Okay. And this, is there any way like you can say this comes closer to fine tuning an LLM? Like
No. Because we are not, the neural network, underlying neural networks not even changed at all. The weights and all remain same.
Okay.
It's the conversational way. It's like a, when very high level, it's like a cheap alternative, right? A quick and cheap alternative to fine tuning.
Okay, thank you.
Yeah, I'm done,
Yeah, quick question from my side. Actually, two. So you, from the example, it was prioritizing based on the constraints that you gave. Is it doing more like a logical operation or is it arithmetically calculating, like based on this calculation, this is the margin I am arriving at?
Thank you so much for your question, but we are running out of time. You can definitely take his question offline.
Sure.
He'll be available.
Yeah, will do. Thank you.
Yeah. So thank you so much for sharing your insights. It was really a wonderful session, sharing your expertise with planogram and all of the code snippets. So guys, just to iterate again, please do share, the pictures that you click in social media by tagging AZConf. And now I think you'll have the refreshment break. So it's there in the 6th floor. So you can just take a break now and be back by 4:15. Thank you all.
Microphone को ठीक से
everyone. Welcome back. I hope you all had a great time during the break. So we are going to go for the final talk today. We have Saravanan, who is going to talk about consideration for LLM ops. So running LLMs in production. So how many of you have done, put machine learning models in production? Yeah, most of us will have done. So even I'm excited for his talk because it is going to give deeper insights on how to do model fine-tuning, all of those little aspects that we have to consider when we deploy a machine learning model to production. So over to you. Stay with you. Okay, guys, we have some connectivity issues here. So, meanwhile, we can just talk among yourselves, or if you want, you can share your experience with us. So
It's
now
done.
that,
Can you check it now? Yep.
all right, I'm stopped from talking now. He'll go.
Hello, am I audible? Yeah, thanks. Hi, so I'm Saradindu. I'm currently working at Noonam as a senior ML engineer. So primarily working on building analytics platform for electric vehicles and fleets. So today I will be talking and on a brief certain considerations while running LLMs in productions. So consideration in the sense not how to fine tune or how to do prompt engine, not on that level, but the things that we don't normally normally don't think about while designing a system. So with that I have to start with, I have one quirky graph. So this graph I took from a post from Weights and Biases. Am I audible properly? Weights and Biases. So it's actually just to show that how the ChatGPT propelled the whole LLM ops and whole LLM applications, everything to the start. So even the basic architectures, transformers, attention models, embeddings, but they are still from 2014, 2016. But it's when the first version of the ChatGPT was released, I think back in 2022, that's when the whole hype and everything started come together. And then when the new development started coming like every day, it's like literal exponential growth. So, so the primary reason for such that the amount of application that is coming because of that is quite extraordinarily, and it's quite fascinating even. It's not just for business use case, just from even for a normal engineer like me, just to play around also. The kind of applications are there is literally very interesting. So this is the one more question, that why another ops? We had first started with DevOps, then went to MLOps. Now we are at LLM ops. I'm pretty sure after 2 years there will be another ops, something XOps. So the primary reason to go into deep on that is that this workflow is primarily how we normally build an ML applications. We start with a base dataset, we start with a base workflow or our own base models or base dataset, and iterate on models that we can understand, or we can explain the inferences on that. And then we start fine tuning, and then we start parameter optimizations, and then when we are satisfied with the results, we go on to build production layer for that. We start with building productions for the production layer for the data pipelines. We start adding data quality checks and everything. And then it goes into model monitoring, model inferencing. But when we go into building applications with large language models, or not just language models, large vision models even, for say, consider the segment anything model from Facebook. The recently released SAM model just for segmentation. So the kind of workflow there is it's a bit different. So this is an overview of a very small ML system where we have the streaming or batch data that is coming from the user side. And then we have data pipelines, we have data quality integrity checks, and then we have inferencing. In between, we have model performance monitoring, everything that you can see, and then you would have definitely built into your own ML stack while deploying even a small email spam filter. So that is one of the, this is one of the very basic understanding of a overview ML system we can have. But when we go into an LLM application or a large model application, things change very drastically. I will just show that in the next slide. Before going there, so on the left side, if you can see the feature stored part, so that is where we normally store the features that we have already in normal applications. When we go to the LLM parts, that part changes drastically, as well as the model evaluation stage. Because in normal ML applications, we do, even if it's a neural network model or normal ML models, the model evaluation phase is quite straightforward at this stage. Even if we are doing explainability, everything, we can do quite straightforward way to see if the model is explainable, it is meeting the standards that we are hoping for. But we won't go into any kind of large models, large language models or large vision models. That part also changes drastically, specifically when prompts are involved in the part. So this is a overview of a small, as a very large overview of a small LLM applications that we can have while running it. So here, most of the LLM application that we build, we are not ever going to train our own models. That is period. We cannot do that because the amount of resources needed are quite huge. So most of us are going to rely on foundation models, either from OpenAI or Microsoft or Facebook, open source, proprietary, doesn't matter. So that is where we start. Instead of starting with data, we start with a base model. Then we go into data. So starting point is also changing when we are going into the large language models, primarily because of resource crunch or because the whole paradigm has shifted. So here, the kind of data that we have is very domain specific, because we have in a large language models, you have a hammer. We need a scalpel. So we need to trim that hammer and to make that as a scalpel, either through prompt engineering or through fine tuning, however it is, however time we have. On the right side, you can see the vector database and embeddings. So I will come to that part later, on the later part of the explanation, why that part is much more important than everything else. So once we have the foundation model, we can do prompt engineering, we can do fine tuning, however we want to do. We can do a normal RAG, knowledge retrieval as well. And then it comes to model evaluation. So the model evaluation parts is another tricky part, where we have to do model evaluation based on prompt, model evaluation based on the output, everything. So, and then it goes to model inferencing. So even if the whole part, before model inferencing, the amount of cost required or amount of time required is small, model inferencing will have at least 90% of that cost and everything. I'll explain that in the next slide. So these are the primarily challenges we can see or we see normally while doing this. So toward the more right we go, we have the known issues, in the sense that these issues we have faced while we were building our own MLOps platforms or deploying ML systems. The more upwards we go, we see the newer issues coming, which is introduced currently with the new paradigm shifts. Here we are trying to build a deterministic system with a stochastic output. So it's definitely going to be very different. So you have ambiguity in the models, you have inconsistency in the models, and then the prompt generation part comes into picture, which is another thing altogether. And then the cost and the latency that is introduced. Even if we are doing batch streaming for, say, any normal simple ML model, the amount of latency that we have to take care of, we can easily estimate that. But here, the latency is quite inconsistent. The cost is also quite inconsistent because of the amount of development that is coming and the kind of model improvement that is coming day after every day. So I just want to touch here on the prompt generation part, because I will skip this part in the forward slides, because there are already very good documentation, very good articles written on that. For prompt generation itself, OpenAI Cookbook is one of the best resources for understanding prompt generation, prompt evaluation, and optimizations. So like we have normal GitHub for our code versions, here we also have a prompt versions, because obviously we're not going to run with the first prompt you think of. You're going to iterate, you're going to see how the model is improving, how the output is improving, and for that you need a versioning system for prompts, not just for your code, but for the prompts. then you have the same evaluation. The evaluation you do on the model, then the evaluation here would be done on the prompts itself. So the two kinds of evaluation that we normally think of in this stage. One is the understanding of the model, or understanding from the prompt, is it enough or not, or is it viable enough or not? Because at the end of the day, you are doing few shot learning with a couple of examples, with a couple of tokens, with a couple of examples. So is it overshooting? Is it overestimating or not? Is it actually understanding the prompt or not? That is the one part of the evaluation. And the second part is the optimization. That's the same thing you do in normal ML model optimization, where you do hyperparameter tuning, everything. Here, you will do the optimization on the prompt itself. So the two major optimization methods is the chain of thoughts, where you a chain of thoughts, and self consistency technique. So where in first cases you try to understand how the model arrived at the part, which is some bit of understanding from explainability, and the second part is you try to get as many as input as you can get, and then try to understand which one is better. So the same techniques that we used to use in normal ML application development, we are using here, but from on the prompt, not on the model. So our whole applications or our whole understanding is going to be on the prompt here, because that is the core starting point, at least at this level. So coming back to the ambiguity and the inconsistency part, on the right side, I just had a small essay there, and then I used it to run on the open ChatGPT. I think this is GPT 3.5. So the understanding is here that I have added the format, how the essay score should be. Any change in the prompt, even a single line, would change the whole structure, everything. How do you manage that ambiguity of the response? That is first part. Second part is the inconsistency. Because it's stochastic in nature, as it should be, as everything is, you run this one again, it might give you different answer. Or you run that on multiple times, it might give you different answer. Depends how you are doing it or how you have structured it. So even if a single thing changes, it will change the output. So that kind of inconsistency or ambiguity will always be there in your application or when you are building it. To remove those inconsistencies, there is literal resources available in OpenAI cookbook, which is used to optimize the prompt engineering part itself. But the biggest part is to build around that ambiguity itself. Because at the end of the day, we are trying to build a deterministic system where we expect the output at a certain stage, at a certain format, on a certain level. But we are trying to do that with a stochastic system. So we have to design our system around that part so that we can take care of that ambiguity and inconsistency. So this is the part I was trying to say, the cost and latency part, which we had looked at. If you look at the top right, the inference cost and the prompt engineering cost, it's almost like the prompt engineering cost is almost negligible. But when you go into the inferencing cost, it tries to boil down, it tries to rise up. I just did a back of the hand calculation with this, with a general output on the GPT-4 and the recently released turbo version. So just a simple token size, 10K, and the output token 200. You can see the amount of cost per million inferencing. Now, if you have amount of inference per million, even if it's serving per month, the amount of cost is going to be high, always going to be high, depending on how you are using it or how your inferencing is targeted. So this is the part that I was trying to come up earlier in the first slide, that the model inferencing part is almost 90% of everything else. Everything else might be 10% work, but the model inferencing part, cost, workload, everything is going to be almost 90%. Yeah. Then comes the latency part. I don't know if anyone has noticed or anything, but AWS EC2, can anyone know what is the average SLA provided for the AWS EC2? Does anyone know? It depends based on the region to region, but it is normally between 97 to 99%. Normal is SLA uptime. So SLA is service level agreement, when you expect that your system will be up by 99% of the time. None of the commercial LLM providers or app companies or whoever provides as a service as an API, none of them provides an SLA. So even if you are building everything based on a single enterprise model, in certain scenarios which are, you don't have a guarantee that your system will be up always. You have seen OpenAI going down multiple times of the year. So this non-existent from an SLA will also come into picture while you are designing your LLM applications. How do you deal with a non-existent assurability or a guarantee that your system will be up always, or your system will be at least X% amount of the time? It is always, okay, I don't know, might be going down, might be up. The primary reason for that is that it's a huge network overload because everyone is using it, because it's in the media, it's a new hype or bubble or whatever it is, but it is the new thing, so everyone is using it. So with that picture in mind, the network cost is also huge. Network overload is also huge. And the second part is the much more important part, because the amount of development happening on that part is quite volatile, in the sense that every new thing is coming every next week or every other month. So kind of improvement is coming. Is also very, with that in mind, is also very difficult to consistently say, okay, it will be up by 99% of the time. It might be up today, it might not be up tomorrow. So that kind of constant volatile development also hampers that SLA part, or the consistency that you normally would require or normally you think of a business application comes from that part as well. Second part is that there is no clear latency mentioned anywhere on any business applications APIs provided. That what would be the latency or anything. So the primary reason for that is either it can be, you can attribute that as a model size, or you can attribute as also engineering overhead. But there you will not be able to, or it is not constantly visible which is contributing to what. So you are always on the behest of the provider who is giving you the API as a service. You would never have understanding of which part is contributing to the latency. You would have understanding if the model is large, if your input size is large, if your input tokens are large, but this is the one part that will always hamper your constant development while building your business applications with a commercial provider or with any LLM providers, or with any LLM open source applications as well. The first 1 and 2 point makes the third point much more relevant. While we build any application, or while we start designing any application, we start to see first, do we need to build, or we can buy it somewhere else? The amount of change is there, the inconsistencies, the amount of cost changes are there. Every week that build versus buy estimates will go up and down. Every week you have to go back, okay, and think, do we need to build or do we need to buy? Whatever we are building, should we abandon it and then should we go back? Because every week, every month, something new thing is happening. The performance is improving. And with that given in picture, the usability is also improving. So how would you determine that do you need to build or do you need to buy? Do you need to run your own inferencing in your own local cloud? For say you are using the largest open source Llama model, which will at least take 128 GB of RAM in a AWS system. So how would you define, or how do you take decisions on that part to build some things in-house, or would you go on to buy that part? That is one of the biggest, would be the biggest challenge while building it. While building as a exploratory part, as a prototype part, it is fine. But while doing that as a business application, this will come into picture very frequently. That do you need to build, do you need to buy, the model needs to be open source, do you need to host it, or do you go with any hosted part as a proprietary service? Given everything that has been released in the OpenAI dev days, almost everyone has started thinking on that line, that do we build everything on OpenAI, or do we go everything with open source provider, with LangChain or Llama, anything. So just this, the lower part, the lower tables, I did this calculations, small calculation myself. So I had this small input token of 51, just 51, and then output token of 1. So it gives at least 500 milliseconds of latency. So I ran that for at least 5 times to even it out. And then I increase the input token size and run it for 20 times. Just to see how the latency changes, or is it actually good, or it is actually does it actually make sense. So on the top two, you can see the output token size is 1 and 1, and the latency is sub-second, at least 90% of the time. But when the output token changes to 26, the latency drastically increases, almost double, because your token size has increased. So when output token size has increased, the parallelism is gone there. Most of the operations on the output token size is sequential. So there, your latency also increased. This is one small part of taking in consideration while you are building your applications or even designing your prompt as also. That how much latency I can manage, how can latency I can incorporate in the application, and how much latency is acceptable. Because if I have to wait for 5 minutes, even 10 or 15 seconds to get output, which I can get normally just by Google search, it is normally not feasible for me to go back there. That this is one of the biggest challenge while deciding it, that how the latency will affect your user experience. Yeah. Next part is, we have done prompt generation, everything. The next biggest part is that fine tuning. So anybody here have dabbled around fine tuning any base models? So when you are doing any fine tuning model, for say you are doing it for your own purposes, or you are doing it for any applications, business or otherwise, how would you decide that normal prompt generation will work, or you have to fine tune a model? Like, where does you stop? Okay, prompt generation is not happening, is not giving you enough application, enough performance. Now you need to fine tune your model based on your own data. Anyone? Whoever has handled fine tuning, have you answered this question, like from a system design point of view? Yeah.
Whenever the problem statement becomes like very specific, then like normal prompt generation won't work. Like then we had to do the fine tuning of the model. Like recently I had to do a fine tuning of an NLP model based on sentiment analysis. So it was not able to analyze random sentiments. So I had to fine tune it on the data generated by myself. So on that data I fine tuned the model, then it started working a little bit better than before.
This is one of the biggest part, that when you need to do fine tuning and when you can just get away with prompt engineering. It can be done, okay, prompt engineering works perfectly fine. It also can be that fine tuning actually reduce your cost going forward. If you have stuck, okay, I will build this application in-house, then your cost will drastically reduce, because everything you are baking in together, and the training, pre-training, everything you are doing. But the same question that he mentioned, I asked, that when to decide which part to go with. Yeah. So as a typical, back of the hand, not back of the hand calculation, one calculation is that one prompt is almost 100 examples. One prompt is almost 100 examples. So this is from a paper released from Hugging Face. The right hand chart is also from that paper itself, where it tries to answer that how many prompts you can, or how much you can do prompt engineering, and when you have to go back to fine tuning. So it's like a questions that you normally ask in a system design kind of interview. Okay, this is not working, now we have to go there. So if you have 100 examples, fine, prompt engineering is fine. But when you have more examples and you are frequently using it, your inferencing cost will also start rising up. And with that in picture, your performance also go down because you have more examples. If you had a fine-tuned model, you would have gotten better performance for less money. So that's when that fine-tuning part comes into picture, that when we should do fine-tuning and when we should not do fine-tuning. I'm not going to mention what kind of fine-tuning is there, how you can do it. I'm not explaining that here because there are literally many articles on that part. So on a cost-wise, this same estimations what they are for 4,000 for 1 million inferences. Same estimation on without fine-tuning. It is almost at least 2,000 USD for 1 million inferences on a GPT 3.45 turbo. This estimation is from the same paper itself. So the calculation for 1 million estimations will almost reduce your cost at least 60% if you are doing fine-tuning. But to arrive at that conclusion that, okay, I have to reduce the cost, will again go back to the same part, that how much data you have and is it actually feasible for your business use case to actually do fine-tuning or not. By the way, I have added all the references at the end of the slides. Yeah. Next part is the embeddings. When you handle embeddings, do you use a vector DB or do you just use as from the OpenAI itself, from the embedding retrieval API itself? So on the right side, the LLM app stack, this is I picked up from a report from Anderson Horowitz, where they have went through LLM abstracts for each and every application that you can find. And vector database stands in between everywhere. Vector databases stand in between everywhere. So it acts as a cache for your own LLM abstract, in the sense that you can retrieve your embeddings much more faster. Plus also generation of embeddings is a one-time job, but retrieval is a multiple times job. When you go there, when you start to try to calculate the cost, that is it good enough to build an embedding store or build a vector database to store your embeddings to retrieve it, or just use a standalone or use a hosted version or enterprise version. That's when the same picture comes here, that if you have a vector database running, your inferencing latency will also reduce, because the amount of retrieval that you need to do, because it is running on a hosted vector database, the amount of inferencing time will also reduce. So if you are running a hosted open source LLM models for business or any personal use case, having a vector DB on the pipeline, on the model stack, application stack, will drastically reduce your cost as well. Yeah. So with that is the full thing that I have tried to explain. I have tried to add almost all the references that I could find that I have used in here. So almost all of the references are added here. You can just, if you want, you can go back to the papers as well as the articles to refer to the estimations, everything. Yeah, thank you. We can, I think, take some questions.
Everybody, if you have any questions, you can ask. You can use this time now.
Hi. Thanks, you covered everything almost, but is there any consideration that we should be aware of for the development frameworks like LangChain or LLM, Llama Index, etc.?
Consideration in the sense while using LangChain? I don't have any consideration for that, like what kind of consideration you can have. That is separate part in that's why I haven't mentioned anything on specific development frame, because if I start going there, it will be huge if that. I haven't have that much challenges on that part because there are good amount of documentation present there. Most of the hamperings, most of the issues comes while doing the inferencing part or while doing the evaluations part, or even for prompt engineering also.
Yeah. Hello. My question is, have you explored the part of evaluation of LLMs? Like, have you tried?
Sorry?
Evaluation of LLMs. Evaluation
on the
part.
model evaluation side, right?
Yes.
Yeah, I haven't went deep on that part. How on the model evaluations part? That I haven't went deep. But
Any exploration, like how to evaluate, for example, say I am using direct inferencing or few shot or one shot prompting for now, and when I should actually go for fine tuning, when I should go for PEFT, LoRa, etc.
so that part is fine tuning. When you are doing when you are considering fine tuning, the same question that you asked, that when you should go back, if you have, do you have enough data?
Yeah, basically if we are building rack-based systems, right, you actually need an external data source.
Yes.
So if the model which we are using is not able to answer things properly, then you need some kind of evaluation metrics, right, to understand, okay, fine, the model is not answering well. So you either go with a different model or you train the same model, that is fine tune or do some other things.
Yeah.
So in order to do that,
there is a recently released paper on that part itself, where it uses the same game theory approach to evaluate the model performance across. So recently it was there in Kaggle itself. It's a benchmark dashboard which uses the same ELO system that chess competition uses.
based on reinforcement learning.
No, it's based on game theory.
Game theory.
Yeah, they have a accompanying paper also.
Thank you.
Anything which you did to solve for the inference latencies?
Sorry?
Anything you did to solve for the inference latencies? Like, for example, in my use case, we had to shift our GPT 3.5 Turbo from West Coast to Paris based. It almost reduced like 1 second of latency. So something like any other thing which you might have done.
Mostly I have run in India region. So I have not moved outside also from India.
Okay.
So even by changing region, I don't know if how much latency it can be reduced.
For me, it went down by almost 1 second, like P90.
Oh, that's good.
Yeah, from West to Paris. Yeah.
So most of your inferencing happens in Europe region, right?
Yeah, so that's what I am asking, like any other thing or any with your experience, right? Any other thing which you might have done to reduce the inference latencies? Like this is one which we had faced.
I haven't tried on changing regions or certain things. Mostly I have stuck with on single region, single provider, just to keep everything as simple as possible. Just to make it as consistent as possible.
Sure. Thank you. That was such a great talk. Thank you.
Do we have time?
Hello.
Hi.
So I have two questions. One is, other than the latency, what are the other engineering challenges when we host LLMs in-house? The second question is, how crucial is or how vital distributed computing frameworks, the upcoming ones like Ray LLMs are? Do they really help in production inferencing, or is it good of only for the prototyping?
Sorry, can you repeat the second one?
The second one is about distributed computing frameworks, which have popped up recently about Ray LLMs. So are they good enough for running production level inferencing, or for prototyping it's kind of...
So I have personally, as my toy example, I was trying to use Ray for that purpose. I don't know if you use Ray for that purpose. It actually improves the timing, at least for that application latency, at least 10% I have noticed. But I have not gone deep, or I have not tried that for any production purposes. I only tried that for my personal use case.
Yeah, I have a question. So based on your experience, which model would be ideal for production-ready applications?
Which foundation model?
Which provider? LLM provider.
It's quite difficult to answer. I can refer to you certain papers which can give you better answer. I have mostly stuck with OpenAI wherever I can because it is easier for me to use it. Plus good amount of resources out there.
Thank you.
Plus also it is difficult to benchmark every single open source application hosting it because it costs resources and money.
Thanks everyone for your questions. Thank you so much for your talk. It was very insightful. Can we continue with this quiz? Yes. How many of you were there for the first time? Like when we had this quiz for the first time? Oh, there are a lot of newcomers. So I'll just repeat the rules once again. So this is more of like a picture connection. You'll have to connect all those pictures and you'll have to make a word out of it. So just to ensure, since many are there, we can't give goodies to many people. So all you have to do is just stand up, raise your hands, and please don't shout your answers out. Rather, just raise your hand, and whoever does it first, they'll get the goodies. Okay? I'll probably... Yeah. Any clue? Please don't shout your answers out. Yeah. No. Yeah, right. That black shirt guy, he gets a goodie. It's platform as service. Can you get it? Or is it difficult? Can you explain? Why is it platform as service? Okay. Snake, okay. Oh, it's PaaS basically. So it's PA and this S for snake. So it's platform as service. All right. So this one. The answer is right, but I didn't know who told it first. Yeah, it's OpenAI, right? This is quite easy. Yeah, SpaceX. Right, he gets it right. It's Eiffel Tower. Eiffel Tower. This, I didn't even show it. Did you by any chance get a copy of this slide deck? It's Mahendra Singh Dhoni. Yeah.
Thank
you. We're done with the, brainstorming, just a quick activity. So yes, we've come to the end of day 1 talks. So how is it? Can we just hear a shout out just like how we did in the morning, just to see the pulse of you all? Yes? Are you all tired? Are you all bored? Okay, so we'll go with the countdown. 3, 2, 1. I think many weren't ready. We'll just start again. 3, 2, 1. Shout out for AZCon. Nice. Okay. So thanks everyone you've been a great audience and, be with this event and also your energy. Nobody can match all of your energy. Thank you so much. And I would like to thank our sponsors, our gold sponsor, Presidio, Zoho, and other community sponsors, community partners. Without them, this event would definitely not been possible. And I have some important information for you all. So if you can just wait for 1 minute, it'll be helpful. It's regarding the tomorrow's, how the day 2 is going to progress. So, most importantly, you have the same event pass for both the days. So tomorrow's event will start sharp at 9:15 a.m. So registrations will open at 8 a.m. Okay, so make sure you check in before 9:15, probably before 9 o'clock. So it'll be helpful. And tomorrow you have 2 workshops. So make sure you bring in your laptops if you're going to attend your workshops. Okay, so this is one more thing. Then you'll have to bring in the badges tomorrow, show it at the registration desk. So you will not be able to get the coupon if you don't show your badges. Okay, am I making sense? Okay, so you will not get exceptions. So make sure you show your badges for getting tomorrow's, lunch coupon and goodies coupon. Okay, and the session timings is going to be the same, just like how it was today. And goodies will be given tomorrow post lunch, probably after keynote. So make sure you attend your event for the full day and get your goodies. So in case of any other, issues, you can reach out to Bhuvana and team from AZConf. They'll be there. And yeah, I think I am pretty much done with whatever I had. So these are the main pointers. So are you all excited for tomorrow's workshop? Yes. Okay. So thank you so much. Just make sure if you are going to post something in your social media, tag AZConf. And have a great day, everybody. Thank you so much.